Okay, good morning, everyone. It's now 10 o'clock, so I think we can start with this online workshop. So I want to start by thanking all the projects that are participating into the organization of the project: 5Growth, 5Dive, 5G, 5G Vini, and 5G Tours. And with that, since we have a very packed agenda, I will move to the next slide. This is the actual agenda. So we have from now until 10:30 a welcome and introductory panel, try to basically set the pace for the different presentations and the motivation for this panel. Then we will go into different presentations / demos from the different participating projects. We will start with one presentation from Manuel Lorenzo on 5G. Then we will go with a presentation from Christos from 5G Vini. Then we will do a short break, half an hour, also to catch up with potential delays that we may have during the sessions. And then we will resume with a live online demonstration from 5Growth and 5G Tours. And then we will have a set of very short presentations or demonstrations from 5G Dive. And at the end, we will have a concluding panel where we will try to discuss a bit on the different experiences and challenges that we, as different projects, we have learned or we are learning in the process about how to do experimentation, 5G experimentation with verticals across multiple EU projects. So this is on the agenda. Then, well, I mentioned this. The goal is to share experiences around 5G experimentation with verticals in different Horizon 2020 5G PVP Phase 3 projects and EU Taiwan projects. We are doing this in an online format due to the COVID-19 situation, but I think we are now very much used to this format, so it's not new for any of us. And I think we will be capable of getting the most out of it. We got more than 200 registrations. I see many people joining, so we are already like 70, and some people are trying to join at this point. So I hope we will reach a significant number. Already the number we have is very good. So thanks for being here and attending to the workshop. This workshop meeting is being recorded and will be posted on the 5Growth YouTube channel in the next few days. So please be aware of that. Although all that you guys that are participants, that you are not actually presenting or participating into the panels, you will only be able to basically ask questions via the chat, okay? Just for making things easier. So questions and participation is allowed, and not only allowed, but very much welcome. So we did the agenda having some time allocated for this, but of course the time is limited, so we'll try our best in allocating time for the questions and the answers to those questions. If you have any question during the workshop, please use the chat, then the question, and we will be basically, as moderator, try to get time for those questions. We will do our best. And I also take advantage of this to request or to kindly ask all the presenters and participants in the panel to try to stick to the time we have, which is very limited, I know. And sometimes I will be asking you to do a 3 minutes presentation or contribution. So please stick to that time in order to keep the agenda time and to also allow for questions. So this is it in terms of the welcome. I try to keep it very short. And then we will move into this introductory panel. So the idea is to have some initial discussion, again, limited in time, but initial discussion about these key challenges and requirements for doing experimentation with verticals with 5G, which is the key activity that these projects that are present here are engaged these days. Now with all the difficulties of the COVID-19 lockdown and limitations, but this is what we are doing. So in this panel we have the set of participants by the different projects. So we have Li, which is from NEC and is the 5Growth technical manager. We have Manuel Lorenzo from Ericsson, which is the 5G technical manager and also the World Package leader in 5Growth. We have Antonio de la Riva, which is the 5G Live project coordinator. We have Marco Gramaglia, which is a participant in 5G Tours, and Christos Tranoris, which is a participant from 5G Video. And with that, I would like to actually open the panel, and I put some kind of motivation questions that you may use or not, but the idea is that you talk about this, summarize what is your view on these key challenges and requirements for the experimentation with verticals. So you can briefly discuss in 3 minutes which verticals are you working with, considering your projects, and maybe mention some of the examples based on your experience of challenges that you have faced or you are facing in order to actually do successful experimentation with 5G and verticals. So we may just follow the order that we have. Like maybe we can start with C. So C, if you want, I don't know if you prepare. I think you prepare some material. You are free to present the material or just verbally discuss whatever you want. If you want to present, I will stop sharing and you can share yourself. So what do you prefer to do?
I will prepare a few slides. I would like to share on my side.
So you can now share. Please be aware of the time limit, okay?
Yeah, you already gave me the right. Sorry.
Yeah, you can present now. You are presenter, so you can go to share content and either share a file or share the screen.
Okay. Can you see? Sorry, can you see?
Now, yeah.
Oh.
Yes, I can see. Yeah, yes.
Okay, thank you very much. So thanks for the introduction. So I am the technical manager of 5G Course project. So I will mainly introduce what kind of a vertical we are working with in the project. So the 5G course aims to provide business and also technical validation of 5G for different verticals. In the project, we are mainly working with 3 different vertical sectors across Industry 4.0, energy and transportation, and we have in total 4 vertical sites, means 4 vertical pilots, and for other different pilots, they are across Italy, Spain mainly, and we need to provide the deployment installation of all the pre-commercial 5G radio transport and core technologies to support the different vertical use cases, and also leveraging the collaboration with the ICT 17 platforms. So very briefly, that for each of the vertical sector, we are working with a set of use cases. So in the family of the Industry 4.0, we are mainly trying to focusing on smart factory and factory automation. So in this use case, in this vertical, we are working with the use cases, for example, to provide remote operation of the equipment using 5G, and also to enhance the machine-to-machine collaboration inside a factory to improve the automation of the factory, and also the digital twin application, also the telemetry and monitoring to enable massive type of sensors to collect the monitoring data from the machines. And in addition, we also have our application to provide some digital tutorial and remote support for the workers to maintain the machines. In the use case for the transportation, we are mainly working on provide or improving the safety control of the railway level crossing. So by using the 5G network, we can remove the cable which are currently being deployed for such use cases, and with the 5G, we can improve the flexibility and also provide a low latency to ensure the safety critical communication between the train approaching detecting sensors and the level crossing controller. In addition, we're using the 5G to provide the video transmission to allow the train driver as well as the maintenance staff to supervise and monitor the situation in order to improve the safety control of the crossing. In the energy sector, we are mainly looking at the use cases to improve the maintenance of the secondary substation on the medium and voltage and low voltage kind of distribution network. And in this vertical, we are looking at the use cases for advanced monitoring and maintenance of the station, also to take the advantage of the 5G of the low latency performance to allow the sensor to send the last gaps, the warning before they turned off. So this is very brief about our vertical and the use case we are working on. So during the project so far, we have found several main requirements from all the vertical pilots. First of all, we will all of the use cases need a 5G deployment, including radio transport and 5G core. And as well, we need the cloud infrastructure at the edge as well in the core area to support the vertical use cases. And most of the use cases will require support of multiple slice type. So in each of the pilot of the use cases, they may request multiple slice to support the services, including broadband, ultra low latency, and massive machine type communication. And in order to do that experiment, we need a portal or a standard interface to allow the vertical to define their services. Usually we will ask them to provide some service blueprint, and this will be required to give into the system to instantiate and onboard their services and specify the experiments. And they also need to collect the monitoring data and as well to evaluate the key performance KPIs. At the end, some of the use cases may also require automated service management over the runtime. For example, auto scaling or self-healing, such a feature will be also required. At the last point, the key challenges we are facing now in 5G Growth project, we are dealing all these three different vertical sectors. They all have some their own infrastructure at the vertical premises, and they wish to have their private 5G network due to the security reason, also due to the privacy. So they would like to deploy the non-public network at their own premises. And this has a requirement as well for to use as well the public network owned by the operators. And the context of the project, this also means the ICT 17 platforms, which provide the resources as well the services for the end-to-end deployment of the vertical service. So facing such a kind of scenario, we need to working on different problems. For example, for each of the pilot, they need to analyze what kind of deployment they would like to have. So according to some standard, like from 5G ACIA, they have released a white paper. They propose 4 different modes of deploying the non-public network. So either standalone, means isolated for vertical deployment, or they can be somehow shared with the public network with different degree. So each of the use case, they need to analyze what kind of sharing they want with the public network. And one of the key questions is which part will be shared and who controls what. And additionally, we need to also define what interface the vertical to request the services to the public networks or to ICT 17 platforms, and what kind of service request they need to ask. Either it's the whole end-to-end service or just a subset of the services. This really depending on the capability of the platform and also what's the business behind for the vertical service, what they would like to request. So these are the main challenges we are facing since beginning of the project, and we are working on right now the solutions to provide per pilot the customized solution, how they integrate with individually with their ICT17 platform, and also what kind of interface they need to talk to the ICT17 platforms. So that's all from the 5G growth side. Thank you.
Okay, thank you, Chi. So please be aware of the timing, as I mentioned before. So we should try to stick to the 3 minutes and try to have some discussion. So maybe you can stop sharing, and then Manuel Lorenzo can. I don't know, Manuel, you want to present any slides, or you want to just discuss about these questions that I proposed?
I would like to just post a slide in the background, okay, and then go direct to your questions.
Okay, so you can do it?
Hopefully, yes. Okay, probably there we are.
Yes.
Thank you, Carlos. From the point of view of 5G, it's an ICT17 project meant and only meant for serving use cases. The approach is that in the project itself, in the consortium, as you can see in the first row on the table, we actually serve a number of different vertical industries already. This is an important part of the project, but it's also a source of continuous learning and improvement, so that we can then, with that experience and with the platform that we are consolidating, also serve all those other projects that have engaged with us for testing similar or different verticals, and in any case, each application is different, specific. The challenges we have to do a lot with this table. We cannot prepare, and we should not prepare for a vertical specific platform. But we can't either go for a very generic platform, going to a common denominator that could be only something like the 5G network gear, or a very common testing platform. The actual situation, and then I'm doing a self-spoiler on my presentation later on in this slide, and I will give you back the floor, is that we have to accommodate for a number of different projects to test their applications, and they have to be as efficient as possible for their own needs, for the needs of the verticals, for the needs of the projects. And this is quite challenging indeed. We come from a world where a full experimentation cycle with a vertical can last very likely something like 1 year. If you're lucky, 6 months. But we want to really make it possible for everyone that we can do this in 4 months, from test design to test analysis. So the 5G network as such is not enough. We were developing a number of innovations and test tools so that you can actually comply this with a high degree of automation in this limited time. We can see a variety of vertical applications, some of them with previous experience in 4G, some of them starting from the scratch, some of them with virtualized applications, some others go into the digital transformation. All of this is happening, and still we want to be able to meet this service level agreement of making it possible that in 4 months you have transited from start to validation testing. So that's the main challenge we have in 5G.
Okay, thank you very much, Manuel. So now is the turn for Antonio. Antonio, are you gonna use any slides or?
Yeah, I have prepared a very short slide, so I can present them.
Okay.
Let me see how this is done. Carlos, maybe you can. Where is this? Share file.
Share content. You can.
Ah, here. Share now. Oh, I was not able to find the button. Okay, very. Can you see my slide set or not yet?
Yes. Yes, we can.
Okay. So thank you, Manuel. Thank you, Carlos. I'm going to present very briefly what is 5G Dive before going into the use cases, because it's a less known project compared with, for example, 5G. So the 5G Dive project mission basically is to have an architecture and infrastructure based on fog devices, okay, where we are able to virtualize over an heterogeneous infrastructure different services that we may need, okay. In order to do that, what we do basically is to integrate HCMEC principles into OpenFog, okay, in general, although we all know that this has changed in the last years, okay, concepts. So at the end, we have like a 5G infrastructure where we can have multiple computing devices surrounding the user and providing services to it. In this respect, it's a little bit different from other projects in the phase 2 or phase 3 of the 5G PPP. One important aspect of 5G Dive also is that we are pushing to get artificial intelligence or intelligence in general near the user. So at the end, our fog devices are going to implement some intelligence services that are going to be used in order to provide this kind of service. So now that we understand these two principles, okay, that are the two main differentiating points, let's have a look to the use cases. That is the question of the panel. In 5G Dive, we have two main families of use cases that are going to be very similar to other projects, okay? That is the Industry 4.0 family, where we have digital twin and the CDM, the zero defect manufacturing, okay? And what we have, the differentiating factor here is the use of the fog, the stream edge, okay, in order to provide these services to the user. So instead of relying in the cloud-like HCMEC, what we are doing is we are trying to push these kind of services into the fog devices and distribute load of computing load across multiple devices providing these services. Of course, as these use cases are very well known, we have the enhanced mobile broadband and ultra-reliable low latency requirements. The second family of vertical pilots is the autonomous drone scouting, where we have two use cases, as in the Industry 4.0. We have the drone fleet navigation and the intelligent processing of images in the drones, where basically what we are going to do is to provide intelligence, well, augmented intelligence in that is augmented with local edge, okay? And what we are going to do is basically to process images in order to navigate autonomously a drone, or being able to detect when there is a fire and if there is some person in danger, this kind of thing. So with this, I close this panel. Thank you very much.
Thank you, Antonio. Now is the turn for Marco. So Marco, I do want to present. Feel free. This whatever you think.
Yeah. Okay. I'm just sharing my presentation. Yeah, just to have some reference. Hopefully, you can see my slides. Yeah, basically, I'm briefly present the use cases we have in 5G Tours, which, as the name says, we are developing our technology around real users, the citizens and the tourists, in three different cities. Turin, where we focus on touristic use cases. We have 5 use cases there. Reims in France, where we focus on the safe city cases, and there we have 4 use cases. And then Athens, in which we develop our technology around the mobility efficient city. So if we go into the details of our project, okay, where we want to provide our technology, we can basically see that we have use cases that are related to robotics, to media production. Then in France, we especially have e-health systems with wireless operating room or optimal ambulance routing, while in Athens, we go towards more IoT services related to the logistic in the airport. And then to briefly answer your question, basically the main challenges we are facing are basically related first to let's say understanding the requirements from the verticals from a KPI perspective, because I mean, how to translate their application KPIs into network KPI is something that is not trivial and has to be carefully designed. Secondly is the specific infrastructure deployment. 5G is very ubiquitous, but there are some cases in which we need some specific deployments in order to meet the requirements set by the verticals. And finally, I would say that the third main challenge is how to actually bring our new algorithm into the network architecture to help the vertical in providing their enhanced services. So how to tailor some enhanced algorithm in the network, like the AI-based, as we will see afterwards, in order to provide these enhanced services. So yes, this is basically it from my side. I mean, of course, if we want to have a broader discussion, we can have it.
Okay, thank you very much, Marco. Let's give the token to Christos.
Good morning. I hope you can hear me. Okay, I have a short slide, but it's okay. I mean to.
Okay, Marco, please. You can stop. Okay, then you can go. Yeah, you can.
Yeah, it's okay. I mean, I have just one slide just to share with you the projects that we are involved in VRAIN. Mainly it's 5G growth, as you have seen, so I will not introduce that. It's 5G Heart, which mainly deals with use cases from e-health, transportation, and aquaculture. It's 5G solutions, again with use cases from media and factories of the future, and 5G Victory, which has use cases from transportation, mainly with trains, use cases from the energy verticals, and also from factories of the future. We face exactly the same issues that mentioned by the previous speakers, so I will not go into details, because as an ICT 17 project, we prepare a platform like Manuel explained in 5G Eve, and one of the greatest challenges two actually, one is to automate things so that we can really fast onboard the use cases and extract KPIs, and the second thing is to integrate these new infrastructures that ICT 19s bring, especially like Zili discussed, non-public networks is something that we need to investigate in the project. So thank you very much, and yes, we will discuss later during the presentation.
All right, Christos. So since we have a concluding panel where we can continue with this, and we will actually continue with this, and I hope that in the final panel we get some opportunities for actual discussion between the panelists. I think it's best that maybe we can move on the agenda for the keeping the agenda time, and then I can pass the floor to Manuel. So please, Manuel, whenever you're ready, you can present.
Thank you, Carlos. Thank you, Carlos. Thanks for the invitation. Please, Carlos, let me know if there's any potential problem with the sound or anything. Otherwise, I will try to give this short presentation about how 5G is cooperating with a number of ICT 19 projects as we speak. Okay, this is what I propose for today. We don't want to give a speech about 5G. We want to talk about the persons talking with persons and making it possible that we advance in technology and we expand the innovation ecosystem of 5G. This is actually the point, what we can do for Europe in this aspect. But of course, I need to at least put the background on the concepts, the ecosystem, the platform, the interfaces that 5G is creating and ICT19 projects are using. And then we have selected 2, 3 cases, depending on the time that we would like to cover a little bit more, so to land into the daily practice what we are doing with ICT19 projects, and even more importantly to me, some lessons learned along this process, because we still have one long year ahead of collaboration, and the more we learn, the better for improving towards the future. So let me share only this picture on the footprint of 5G Consortium with, I think, a unique combination of companies around 4 national clusters of validation in France, Spain, Italy, and Greece. It's not 4 different projects, it's one project with 4 sites, and that's important. We stick to the same practices, tools, platforms, software, but importantly as well is that at each location we can have different combinations of technologies, vendors, orchestrations. So that brings the real world sort of feeling to the people who are coming to our testbeds to do their validation work, because they have the opportunity to interact with a commercial network, but they are treated as friendly users who can actually validate in whatever ways their application. And that's an important aspect of the project. I was commenting, and I will not spend more time on this, that we believe that it is necessary and possible to shorten the lead time of the validation test of 5G. We have to think in large corporations, we have to think in startups. These cycles of validation of your 5G ready application have to be shorter and shorter. And it's all about simple tools and automation. That will not remove the necessary time of people talking to people, for clarifying the requirements, for speaking the same language, for having a clear motivation for the tests, and for learning, so that actually this process will be faster and faster as we keep on moving. But it's important to have this in mind. We cannot really dedicate a testbed for 1 full year, among other things, because in 1 year we have 2 upgrades of the whole technology, and that's good for the project because we can retest with more technologies and be closer to the commercial reality coming in the 5G deployments. We have commented that we have a huge responsibility to serve our native use cases in the project, as well as the engaged associated use cases of a number of ICT19 projects and others. And this goes up to 30 use case families as we speak, and concentrating a lot about around this moment in time and along the next full year until June next year, and with some extensions to some use cases. This is the plan, the master plan for the year when it comes to cooperation of 5G with ICT19. We are using since mid last year our platform for the verticals in the consortium. This serves the purpose of validating the tools and the networks that we have deployed in each of the 4 locations. But more importantly, we are making sure that we can serve maybe not 100% of the specific requirements, but 90% of the general requirements of the projects we are working with. This is the main task in the first half of this year, and the target itself is moving and evolving. As I was commenting, we have a major release available to all the projects on 1st of July 2020, with an upgrade of both the infrastructure and the testing platform. And we will continue with that along the second half of the year, coming as much as possible as we can to SA and release 16. So that's a short introduction, as I promised, on the 5G concept and ecosystem. And I want to discuss a little bit an important point. Since we are running in parallel ICT 17, ICT 19 projects, this is new. So you can't really wait until ICT 17 platforms are ready. You have to catch the train, to get on the train, on the bus as soon as you can. We went for the approach for creating a roadmap, public and committed by the project, so that you can decide for any of your use cases and test cases to use 5G platform in periods of 6 months. So you can start in January this year, in July, in January next year, or after summer next year, because we can guarantee these 5G 5G capabilities in all sites that you can read here, so you know what type of technology you will be benchmarking or validating your application against. And on the lower arrow, you can see the support level that the testing, the platform that you get from 5G can give you. With regards to the flexibility of testing, the KPIs that are both delivered and monitored, the level of interworking that you can have if you want to have a single site application or if you want to use several sites. And of course, this happens in concurrency with other projects, so we need to use time wisely. This roadmap is a way as well to simplify the life of ICT 19 projects. They don't have to come to specific deliverables to check this or that in 5G projects, but they can know where they can use the platform. Time matters, and this helps with concreteness and with planning. Then, of course, the general assumption is that ICT 19 projects working with 5G are using the well-developed and deployed site facilities that we have created in the project, in these sites 1 to 4 in the countries I was explaining. But we also offer the possibility for a project to integrate their site with our platform. So making it part of this ecosystem and using the same way of working, the same way of testing as we do, not having to improvise or customize for that. In general, this could be very simple, and actually I believe it is. But 5G users are basically testers. They have developed their applications, they find a way to deploy it in our site, and test it. That can be as sophisticated as they want, or can be as basic as they want. Sometimes you are in a rush, you have to produce a result before a month, then please come with us and test the simplest test case you have. If you want to have a broader reach, test more sophisticated aspects, plan for a more sophisticated test. But the whole thing is that you are using the same tools and the same philosophy for testing. And on the left-hand side, we are not precluding any type of devices. We are welcoming that you bring your devices for testing. Devices in 5G, you know that is an overloaded term that can be a bus or it can be an AGV. But of course, the important thing is that it can become compatible with a 5G network to the extent that you want to reach. You may be interested in connecting through a CPE, or you may be interested in using other ways to get coverage from 5G in our sites. So with those two aspects, you are welcome to come to our platform. And in a very simplified way, again, what we offer is, in this nested picture, maybe it's good to explain that, we offer 3 levels of interfacing, from the simplest to the more versatile. Interface number 1 is an intent-based API. This is basically about declaring your intent to do a test in something very close to natural language. And the platform will propose you what to do and will do a lot of work for you so that you can avoid some engineering if you like. Normally, projects go for interface 2. It's a full platform service with a graphical user interface, allowing you for starting from the scratch any configuration of your test cases. I will give an example later on. And finally, we have learned and we are offering as well the same level of functionality through a REST API that can be used for programmatic interaction of your project with 5G EVE and removing here and there some manual or human interventions if you need so. That's for the interfacing. And for the integration on the lower part, you can see that not only we offer the facilities in Athens, Madrid, Turin, and the constellation of sites in France, Paris, Nice, Rennes, but we also welcome that you integrate some of your facilities, the ones you are developing with your use cases, in the same ecosystem. And that's by virtue of the 5G interworking layer, creating the abstraction to actually make it possible to extend and to interoperate with other sites. So that's the general picture on 5G. We were commenting that it's all about the transit from test design to performance evaluation and analysis. It's a journey that the vertical has to do, and they can count on the support of universities, SMEs, vendors, operators in the process. But it is actually on their interest to do this. And for along that transit, we have identified the roles that have to be involved and a process for passing properly from one stage to another, and not preventing that you can run a second cycle of iteration or a third or a fourth, depending on your project needs. I will skip this. We have a jargon that is based on well-known technology from previous 5GPP projects and in standards, but we have come to the conclusion that it has to be possible to express in an abstract way how your test case will be. So we talk a lot about blueprints, the vertical service blueprint, defining your logical components of the use case, how they interconnect, service level parameters, configurable parameters. That's for the service. But then on the conditions, you would like to test this in different conditions. So for that, you can create context blueprints, introducing whatever things you are worried about or you would like to check. Maybe let's put an artificial delay there, or let's throttle traffic in this point. And of course, you have to come to a network service descriptor, and from a family of potential test cases, you can make it more concrete and customized to a specific experiment execution, and that is what you would do in the final step. Putting it in an example, and I didn't select an ICT 19 example because I think this was simple. This is an example we just demonstrated last week, actually. If we take this simple case of a simple case of a sort of remote mobile TV set who is going to transmit over 5G recorded video in 360 degree so that it is accessible for people all around the world with VR glasses. And as you can see on the right-hand side, then this simple use case of upstreaming information of a high bandwidth to the internet can be modeled, as you can see here in the blue boxes, is the application part, devices on the left, applications on the right. Those applications can be in the public or at the edge in the 5G location itself. In the middle, you have the 5G network gear configured for your application. And on the right-hand side and below, there's the machinery for the metrics collection framework. Working for you, working for your use case and your test case, collecting what you need. And in order to do so, we provide the flexibility for you to select the probes that you're interested in. As you can see, there's one by the 5G PC, or the probes that you can add or use from other members of the ecosystem, as the one you can see in the production and ingest server. So when you come to this picture, simple picture of the use case, basically all the work is done for filling out the blueprints I was mentioning, uploading and defining the experiment and scheduling for its execution. Because all this picture translates into a text representation that is as simple as this: the definition of the atomic components, the endpoints, the connectivity services. That is an example, a real case example of vertical service blueprint. This is an experiment blueprint where you go more in depth into the concrete KPIs and metrics that you're interested in, as I was mentioning, to be deployed dynamically and executed in your experiment. And from the concept to the blueprints, and finally to the tool. If you want to use the portal, or if you want to do it programmatically, that's your choice. Then it's all about having these roles accessing the platform and the services to make it happen. If you complete the process, go from one screen to the next, then luckily you will get very soon to the actual execution of the project, of your test case. Here, following the example I was giving, I will show you how it can look like. You can make it look like in other ways, but in principle, this is the VR 360-degree use case I was using as an example. You can see in the bottom part, actually one of the rooms in 5-tonic lab with a 360-degree image. I'm sorry, but I can't project it as if you had VR glasses, but at least you can figure out how it is. It's like a word map with left goes to right. This is being projected in real time. You can see that we also provide remote access to some of the terminals we have, so that you don't have to even walk inside the facility to launch your experiment or touch upon devices, CPEs, and terminals. You can have a visibility of that. That's an accessory. But the important thing is what we can read on the right-hand side, is that you can verify your assumptions on the KPIs. You can verify the behavior of the network in the conditions you are putting. And in this case, the actual important requirement of this use case is the possibility to upstream all this amount of information. The input we had from this use case, it was that 50 megabits per second were needed for 180-degree transmission. And the outcome of the learning of the process is that with half that bandwidth, it's very possible and with very good quality to transmit 360-degree video. Type of learnings that you can have in this iterative process. We set KPIs, we check, and we learn. And that's valuable information for the use cases you are serving for the verticals, because then they can decide where they can deploy and in what conditions, local conditions, they can go live in the market. So I will not make it longer for this. I think it's important to explain that the process I have explained is the same for all verticals to our and that with each experience, not only you benefit, but we learn and improve the platform. Okay. I was saying this is a cold representation of metrics in the system, verifying that things are in line with your expectation or finding surprises, good or bad surprises. It's all about learning. And in this case, it was a very good performance between the limits. But what matters is your case. I think I'm doing good with time, but use 10 minutes to discuss on the concrete we are serving. The important thing, as I was mentioning, is that it's clear what you want to achieve. With that, we have half of the work done. These are the 6 W questions where we have to have it clear. Why are we doing the test? There has to be a clear motivation, a clear selection of your reason for doing the test. The what has to be in place. If you want to test your use case, your application has to be developed, virtualized, ready for play out in a cloud environment as we have. The how, a few selections, but important selections on the conditions you want to check, emulate, play around, then the type of measurements and how you want to do them. We are supporting from, as I said before, from a very simple early test of your use case, plug and play over a static or a common network, so to say. From that to bring your own metric systems, bring your own applications and probes and deploy it. So you can choose in that range whatever you want. The where is important. This is something interesting in our project. You might have your interest, customer base, whatever, in a place, for instance, in Athens. But you could actually test remotely that same use case if you want in any other facility in the 5G system. You could take your test to Paris or to Spain. Same definition of the test. That's important for your possibilities to maybe expand your business or for using the platform when available. But of course, you will have a preferred place to do your test. That's natural. And we serve you in these 4 countries. The when is important. Some tests can test 2 days or 2 weeks or 1 month. And the important thing is that you are doing it against the technology that you are more interested in. You may be more interested in NSA or SA or or you would like to test with edge computing or with public cloud. Whatever you choose has to do with also with the when and the who. It's a lot of automation in the platform, but it's people who fit this with intelligence. It's people who have to be skilled to do this and connected to the people who can help you. So this is super important, and it's not something like, I mean, it's a self-service portal, but it's important that we are in contact with each other for accelerating all the activities and then go to the automation of the execution. So all these are the questions, the dialogue we have had since mid last year, 2019, with a number of projects. We have discussed a lot about KPIs, some assumed KPIs and expectations in the tests, and locations and integration. If I can take the case of 5G solutions, over this simple diagram of what they can do with 5G platform, in this case, Turing has been selected regarding 5G Eve for the validation tests. From the very beginning, this project made it clear what they were expecting from the platform. We were explaining what we could offer them, and they made the selection to go for both using the portal GUI and make use of the REST APIs. And the tests are located in Turing facility of 5G. It's important to understand that it's probably 5G solutions who can benefit from all this work done in 5G, but we also benefited a lot from learning from their cases. We were agile enough to be able to expose in different ways in REST APIs the part of the functionality that we have in the portal and expose it in the same along the same roadmap. 5G solutions as well, they are beta testers of our platform. Some things can take more time because of that. At the same time, they can influence more in improving it with the improvement areas they can find. And it's a good experience from the beginning, and it has to consolidate now in the project plans along this month and the next 4 months. We have important milestones. That is a collaboration case. A very different one is 5 Growth. In here, we have interesting aspects of how they want to use the platform, because not only they want to test use cases and validating, but also incorporate features, innovative features of testing that the project is developing itself. So we have like two levels of integration. Going to the selections of that this project has made, they will use the 5G platform portal and the REST APIs, and there will be integrations of different scope in Turin, the Comau factory of Turin, associated to the Turin site, operated by TIM. And in Spain, we go well beyond the great area of Madrid to Bilbao in the north of Spain for the factory of Innovalia in zero defect manufacturing use cases. And we are using the full potential of Madrid facility for an early stage of validation, and then performing all that validation in the target premises in this factory, being interconnected to the central network of Phitonic in Madrid. So a number of possibilities, as she was describing, Chile, in this ASIA model can be tested with a single use case. That's a source of learning for all of us. So I was commenting on this just for having a self-contained material for you. It's very important for this project to automate. It's also important to have as much flexibility as possible to reach to the control of everything involved in the use case. And it's very important that we focus on this family of non-public network use cases and see how they can be served from an ICT17 platform. Okay. And about 5G tools, this is, I would say, probably the most intensive ICT19 project on 5G. As you can see, there's strong links with our facilities in Athens, with the ICT19 location in Athens Airport, with our facility in Turin, connecting to nice spots, museums and areas in Turin city, and in Rennes, connected to the hospital. So it's an interesting case of extension in a nearby location of the 5G EVE footprint for serving the vertical purposes, and with an agreement at site level to even extend this beyond the official duration of 5G EVE. In this model, it's the GUI, the portal GUI, what's being used by these use cases. And again, this is a project that has also the benefit and advantages of being pioneers in using 5G portal. We welcome that. All the learning is good for all of us in that respect. And as I was commented before, we don't want to hide the real world. We want to expose it. And in this case, we have also an interesting test of the ONAP fabric that our colleagues in France have created for 5G, so that we can verify with this orchestration system that we can extend the platform. So as I have been trying to explain that 3 very different projects have made their own choices, are actively working with us and planning for the next months. And we, of course, I couldn't talk about all the projects we are working with, but I think it could be representative. On the lessons learned, with the probably 2 minutes I have left now, I think they could be clustered into these 3 main topics. This level of flexibility that we offer is for ICT19 projects to use in a smart way. And this is important to think twice about it, because it's a sort of a gift with 2 sides. It's possible for you to do as complex, sophisticated test case as you want, and please do them if you need them. You can actually plan for anything. You can touch upon all the possibilities of the 5G technology. At the same time, there's nothing preventing that you can have your first Hello World test of your use case in our platform, benefiting from creating a very simple blueprint, declaring the basics of your use case, and then coming into play. This is important, and we believe in this. We believe that the sooner you can start learning, the better for planning the whole objective of your project. So That's the philosophy that we are proposing, but it's your ultimate decision in ICT-19 projects. Then the second point is it's planning. ICT-19 projects carefully plan validation campaigns of their use cases. This is important for their planning, and it is important for 5G to be able to accommodate that. In general, and in the circumstances we have, we foresee that there will be a sort of a accumulation or concurrence of tests after this COVID-19 very tough times. And again, we are confident that the level of automation and efficiency of the validation test in 5G can serve in not creating a bottleneck for you when you have to perform your test and maybe you have only 1 week or 2 weeks because there's another project and use case waiting for that. But for that, we have, I think, a good plan. Of course, one thing is the time that you are using the labs, and another thing is that you have to prepare for using the same language as we do, understanding the tools, and it's important to plan for training and for hands-on experience, and you can do it in whatever order. We have delivered training sessions in February, in May. The next one is on the 23rd of June. You just have to visit 5G webpage and register for it. But you can also contact us in through the email address or through common partners. So if you want to have a first show or a first try and start developing the hands-on experience, that, as I commented before, can be done also remotely. And the third point, maybe obvious, maybe a must, but a reality. It's collaboration what makes the difference. You can learn A to Z how 5G works, and then try your first experimentation, but maybe it's not as efficient as having a direct talk with any of us in the different sites or in the different partners involved in the consortium. Actually, we are seeing that those common partners to 5G and ICT-19 projects are playing a key role. It's an instrumental role to clarify on things and to help and accelerate the process. Overall, what I wanted to say is that we are very glad that we are coming to a project that delivers something like a product, a platform to be used. We are on time along the next full year to do a very good work together and to exchange the learnings of each use case to other use cases and to keep improving the platform. It is not closed. It will be improved and upgraded along the next months as well. So that was the experience for 5G, Carlos, and I hope I could stick to time.
Thanks, Manuel. Thank you very much for your nice presentation. There were any questions on the chat, and we got one, so I will shoot and then try to answer in 2 minutes. There is one question that is about is there all use cases in only technical validation trials, or there is also any work towards to business models to apply in real world?
Well, actually, all our vertical partners have the second point in mind. This is, to be honest, more focused in general on the technical validation of KPIs, but there's this correlation with the aspects. I think business model in 5G has to be understood a little bit more broadly. As I said before, if you happen to find out that the requirements of your applications can be more relaxed than you expected first, because of fact-based experimentation, then that can open to more opportunities in countries or markets where 5G is still developing. That's an important aspect. I mean, we want 5G, we want super 5G applications, but sometimes we discover that you can start your business with 4G and evolve to 5G in this aspect X, Y, and Z. So this is the type of learning that we propose our vertical partners to reflect in their validation reports. I found I measured this, I learned this, and this is the consequence or the benefit for my business plan.
Okay, thank you very much. And one last very short question. When is planned to have SA connectivity in 5G?
The plan for, okay, good. In the roadmap I was showing, it's the general roadmap with the minimum requirements on each of the 4 sites of 5G. SA is roadmap to December this year. So meaning that it's accessible beginning of January next year. That's the common requirement to all sites. And then each site can anticipate that deployment to maybe October, September, or even August. And that's why I was commenting that timing is important. If you are interested in that type of test and the facility can support it, you can use it. The important thing is that we are always publishing what we support in all sites so that you can port your experiment from one site to another. So as I said before, maybe you are located in Spain, but you have the possibility to test that in France. And France can have that capability in October. Go and talk to us and to the site in France or any other combinations. But of course, the roadmap will tell you what is available in all the places, and you can trust that.
Okay, thank you very much, Manuel. So then I think we can move to Christos.
Thank you.
Thank you. So Christos, please go ahead and share your slides.
Hello.
Hi.
Yeah, I'm trying to find the setting.
You go, I guess, on the right-hand side, you should have like a menu thing, and there is a share content button just close to the settings one. And then there you can share.
I need to upload my file.
You can upload your file or you can share your screen, whatever you prefer.
My screen. Yeah, okay. Wait, just one moment. Okay, I hope you can see my screen.
Yes.
Can you see my screen?
Yeah, and then I guess you have to put the. Okay, we can do it. Go ahead. Thanks.
Great, perfect. Thank you very much for the invitation on today's session. I will give a brief overview of how we make an end-to-end service specification and deployment in 5G VRAIN, what is the onboarding process, and how we try to tackle with all the challenges we have. So for those that they are not familiar, 5G VRAIN is an ICT 17 project. Already now it's closest to 2 years. It's a large consortium of 23 partners around Europe offering 5G facilities, allowing to test various 5G KPIs. We have onboarded currently 4 ICT 19 projects collaborating with 5G VRAIN. Now, the 5G VRAIN facility it consists of different facility sites operating technologies that are commercial or open source. And of course, we rely on an architecture that is around standards like the HNV or 3GPP to facilitate interoperability. To provide this isolated service experimentation and also have a kind of reproducibility, we see, of course, the slice as a network slice as a service. And the facility architecture offers a catalog, which is service offerings catalog from 5G VRAIN. We have defined the portal, which is a single entry point for the vertical. Of course, we have multiple interworking sites on different geographic locations. So having all this architecture, we need to follow these well-known standards by ETSI and 3GPP, like, for example, to enable interworking or to enable interconnectivity on the resource level. So from our experience with experimentation throughout the years with multiple facilities, we need to define a model-based, let's say, service template and around the service ordering of this network slice as a service. So within VRAIN, we, apart from defining the four known, let's say, service types that have defined by 3GPP, we have defined what is the service topology, what are the service attributes, and how we will involve monitoring and testing throughout the service ordering and service instantiation. And through our designs, we went by extending the GSMA's generic slice template definition to include them. So this is an example of how we modeled in detail the generic slice template to a well-known model from the TM Forum. TM Forum is a well-known organization, especially in operators. They make a lot of catalyst projects since many time now. So adopting this model allows us to work and interoperate with many services and technologies that already are deployed in many operators and facilities. So there is a work here to map the definition of the GST to make, let's say, machine consumable representation. And then we took this model and we extended to the VRAIN service blueprint. So we have a detailed information model for the entire 5G VRAIN facility. So this allows us to reproduce a service definition, that is a slice definition or experiment definition, to facility being what we could say a site diagnostic design. And this, in our view, ensures reproducibility, at least in the highest level of the ordering of a slice. Now, one of the most difficult things that we need to guide the verticals for 5G experimentation is onboarding. Within VRAIN, we made some discussions to see how we can really make this facilitate this process. So, of course, is a process that all stakeholders need to discuss, co-design, co-develop different things. And we have 3 different periods of this onboarding process. The first one is the co-design period, where we discuss with a vertical and we install parts of the use cases in the target facility, since many verticals have, of course, hardware equipment, like their own servers or video cameras, CPEs, drones. So we need to understand the use case and start integrated with the rest of the resources of the facilities. And this helps us also to understand the network requirements of the use case of the vertical, where we need to measure, what needs to be automated, and what we can parameterize. Then after this initial understanding period with the vertical, which is something that we do with all ICT 19s, we have a develop period which we try to co-develop and guide the vertical to develop some things, because the vertical needs also to adjust to the 5G world. So here we have 2 parallel tasks that needs to be done. The first is the network service design, what's also called the resource-facing service design, and then is the customer-facing service design, which is the higher level view of the vertical service that in the end we would like to provide, not only to the vertical that makes the experimentation, but generally in the community of the vertical. So if we go to the network service design, what we need to do is to create the NAV world artifacts, let's say, which are vertical network functions, design the network services, and understand what are the requirements. And then we need to iteratively onboard these artifacts to the target facility, to the orchestrator. Here is a crucial point because we have different orchestrators, different underlying technologies. So we need to see if the models that they created are compliant with the target facility. And at this point, we need to make some VNF testing. And here again, to understand and automate these measurement points. And also involve some services that we have in 5G VRAIN regarding monitoring and testing in the resource level. This helps us to do a sort of kind of pre-validation on KPIs via the NAV orchestrator, and this helps us to see if we can properly extract KPIs from the underlying network service designed. And of course, this cycle happens iteratively together with the vertical and the facility, because this NAV orchestration is a key part to repeatability. And at this stage, we discuss also with the vertical what is the access level that it wants in the facility. Some verticals just want a high-level access, no VNFs, just the pure 5G system and access to the radio. But some verticals would like to have a more deeper access. They would like to involve the MAN orchestrator. They would like, for example, to have access to the OSM itself. Some verticals also would like to have access to the cloud infrastructure, to the NVI, or to the radio. So this depends on how the facility gives access to the verticals. Now, when we have a good understanding of the resource-facing services and how this can be orchestrated by the network, then we go and design a high-level requirements. We try to move to the service world because we would like to offer this network service as a service. So we need to design this service blueprint, this high-level specification. We need to move to this generic slash template. So we follow now to the customer-facing services is what the users will order in the end of the day. And we start to design this specification with its characteristics. For example, where is the region to deploy the service? What are the high-level requirements of bandwidth? How many UEs you would like to have, etc. And then we include the test case design and test scripts from the testing as a service. There is a test deployment activation of the service blueprint because we need to repeatedly test the service blueprint if it works. We need to launch these specifications in various tests, and then we do again a pre-validation KPI that the combination of the service orchestrator now and the NAV orchestrator work as expected. And here, this step is very crucial and needs some time to be consumed here to understand the service specification from the slice template. We need to map it to the network requirements. So this needs some kind of intelligence between this transformation of what the upper layers wants, what the service wants. For example, the customer would like to have tomorrow 2 hours for a certain location event, 4K definition broadcasting. So we need to understand what this means as a high-level requirement to the underlying network. We need to understand the monitoring and testing requirements, and then we iteratively understand and check this development and interaction between the service orchestrator and the NAV orchestration. When we are ready and we have developed and let's say test the environment, then we proceed to this operational testing KPI period, where is the actual testing is done. The end-to-end service order is fulfilled. We have the testing and the final assessment of the KPIs. Again, iteratively, this period happens in order to better extract the necessary requirements. So in the end, the goal is to offer a service blueprint to the vertical community for repeatable deployments. If a vertical from the media or energy sector will create a service blueprint, a template that it will be reusable for the domain, for the vertical, for the automotive domain, for the transportation, media, for the factory, etc. This is the ultimate goal that we would like to have, and create a repository of reusable service blueprints. Now, how we instantiate this service order in end-to-end service resources? So we have the VRAIN portal, which contains this VRAIN service blueprint specification. Actually, we see this as a bundle of services which might involve service specification from multiple facilities. And then the vertical use case go to the portal, define characteristics for the slice. This is part of the TM4 model of service specification. Then again, we use Open API model to do the service order. The service order then is brought to the service orchestrator of each facility, again with standardized APIs of TM forums. This concludes the service order fulfillment. Then each facility service orchestrator makes, let's say, choreography with the NV orchestrator, and we prepare the underlying network service where physical network functions, virtual network functions are orchestrated to provide the radio, the core, and the transport on each facility. So here, then we create the abstract services that make reference to the resources that they implement the end-to-end service. So we have the slice operation in the definition of an end-to-end service, while we have the resources implementing the actual end-to-end service instance. Then the vertical can modify the running service through, again, the service inventory API, either through the UI or programmatically. These are the UIs. We use an open source project called OpenSlice, which we develop within VRAIN. I have some details later on. Since we would like to have this also as a self-service kind of service, we offer, let's say, two kinds of portals. One is to allow the vertical to manage its own NV artifacts. So the vertical will go here and onboard VNFs or NSDs to the target facility orchestrator. And then we have the services artifacts, which is here we define the service blueprint and the specific characteristic of a service. This is a view of example service catalog. The service catalog are, of course, organized into categories. Here, again, the APIs that we use is well known to those, especially to those that are involved in the world of operations. For example, the service catalog management and the resource catalog management. But also, of course, here we can manage the characteristics of a service. There is a complete service ordering and service order management together with a service orchestration. Again, there is an open API here that external services can interact with and make service orders. And during the runtime of the service, they can interact with the service inventory management and service activation and configuration. Now, OpenSlice, as I said, which is the underlying technology that we develop in VRAIN and is installed in the main portal, but also in every facility. Apart from the UIs, as I said, offers open APIs for programmatic access because many verticals introduce their own services that they would like to interact programmatically with their own tools and services and orchestrators with the facility. So many APIs are in place, and we offer a flexible microservice architecture that enables expansion of the service. Last but not least, we work also on multi-domain scenarios and federation. Different organizations can exchange service orders and service catalogs. This allows us to easily interact at the operations level with other facilities. We can exchange services, we can exchange service orders, and in this way, one facility can order a service from another facility. Yes, of course, you can have more details on what we offer, because I think this is interesting to the ICT-19 community, how to at least interact with the facilities in the upper level. The verticals can have more details on the URLs provided, and there are many demos. In the time that I have, I hope that I have 3-4 minutes. I hope you can hear me. Can I have 3-4 minutes?
Yes, but
yes, okay.
no more than that to have
yes,
some time.
Yes. Last but not least, on the YouTube channel, which I will go you through a little bit today, we have a demo that goes from the upper layers of the service ordering to provide a network service to a vertical. Actually, the service vertical goes to a facility, for example, here in the Patras 5G facility. It will order this network service, which includes the radio, the core, VNFs attached to the network. Also, there is Prometheus and NetData monitoring services. So we orchestrate all the environment end-to-end from the service order down to the operation. Here is the link, but just to show you really fast. It's a 10-minute video, but I will go really fast. This is an example from the patras5g.eu portal. We have an instance of OpenSlice. As I said, OpenSlice is open source, so you can install it wherever you wish. So if we go to the services, there is a services marketplace for the facility. And then you go to the catalog, you go to the services. We currently have 2 examples, 2, let's say, hello world examples. And when you log in, you can make this service request. You can quickly examine the service that you will order. This is a monitoring example with 5G new radio in non-standalone. So you will order this service. You see here example from the catalog and how this, you get an underlying description of what you will get in the end when we deploy this service. Our goal is to deploy this service in minutes. This service from at least this one, it takes around 10 minutes to 12 to get it end-to-end involving the radio and all the equipment. See, here is an example from the service order, for example, where the user defines some parameters. Here, for example, is the IMSI of the phone that we will get. We go to manage service orders. I will go really fast. Here is the service order overview. Now, this service order go to the different orchestrators, to the service orchestrator, to the NFV orchestrator. You get emails from our ticketing system while the service is deployed. So you know when is everything is onboarded, when it's active or it's failed. Now, for example, it's reserved. After a few minutes, the service is deployed, is active. We have a lot of details of where it's running, some IP addresses that you connect. For this experiment, we have public IP addresses, so there is no VPN needed. But of course, in next services, we will provide a VPN for the vertical. And then after a few minutes, the service is ready. Is active, so we go to the provided URLs from the underlying system from the orchestrators. Here is the running experiment. I will go a little bit down. We got the IB. So, for example, here is how we deployed our monitoring system for the specific service order. So you've got within your network service, within your slice, we include also monitoring. So this is your, let's say, monitoring service. So here we just have included the mobile phone in the facility, monitoring for the UE, etc., etc. So, but this is a 10 minutes video we can find in the VRAIN channel, and of course you select the period of the service order, how much time you would like to reserve the facility and the resources for this experiment. So thank you very much. I hope I was on time.
Thank you, Christos. So even though we are a bit late, let me ask one question that she put on the chat. So I would just take one of them. So she was asking that during the onboarding phase, it is a manual or automatic process to translate the service blueprints to network requirements and prepare an onboarding plan. And what tools are
currently Currently, the process is automated. What we do is that we pass the parameters of the service definition, most of them, down to the NFVO. This is the simplest case. Now, what we do also in OpenSlice, we include some business, from the world of business orchestration, we include some templates that map characteristics to network requirements. You can find some details in the OpenSlice service orchestrator, how this can be done. This is a huge research, actually, that we do in VRAIN, and we need the help of verticals here. This is our goal, to start understanding the characteristics and how we need to transform these characteristics to the network requirements. So yes, this is happening automatically currently, but by just passing the service requirements down to the NFV orchestrator of the facility. But as I said, we need some intelligence here. For example, if the vertical requires, let's say, an abstract parameter, let's say that I want tomorrow 2 hours 4K video on Athens on a specific cell, then we need somehow to translate this intelligently to the proper radio. I mean, to the proper physical network function. We need to translate it, to the network requirements.
Okay, Christos, thank you very much.
The format of the slice template is modeled on the service specification of TM Forum. This is the format of the service template. There are many details of the of the JSON format in OpenSlice, and actually specifically with 5G solutions, we have made a good progress that with their tools and their orchestration, we can exchange service specifications and service orders.
Okay, Christos.
I answered your questions.
Yeah. Thank you very much. And let's shorten a bit the break. So we keep the original time for resuming. So we will resume at 11:50. You can leave the session and join, or stay. I will keep it. We'll keep it open anyway. Okay. Thank you very much, and we will resume at 11:50. Thanks. Okay, guys. I hope you can hear me now. And we are back. It's 11:50. So we are going to continue with the agenda. Now is the time for live demo by 5growth and 5G Tours, and we will start with some introductory slides from Marco, I think, and yes. then we'll move to the actual demo. So Marco, the floor is yours.
Yeah, thank you very much, Carlos. Yes, I will be quick in introducing this work called vrAIn, a deep learning approach to virtualized radio access network, which is a joint collaboration between the 5growth and the 5G Tours project, based on that paper you can see at the bottom of the slide. So, Andrés, if you can go to the next one. Basically, the new requirements that the network management imposed from 5G networks and beyond perspective are very challenging, because we move from one monolithic instance of the network to a network which is composed of different slices that provide different services. This makes the network management much more complex than it was before. And there you have 2 examples. For instance, resources shall be dynamically assigned to different network services, and the possibly different QoS requirements that different services have should be monitored and fulfilled in real time. Traditionally, all these tasks have been performed by human intervention, so new requirements usually involve some network engineer going there, changing some parameters. In this new paradigm, we need something that is much more flexible. So next slide, please. So for this purpose, AI is the right tool because it, first, it takes advantage of the large volumes of data that these new networks, such as 5G networks and beyond 5G network, can produce. And it provides a proactive way of managing the network. So, for instance, forecasting and exploiting the upcoming behavior of the system. So all the algorithms that usually are included into the artificial intelligence superset, so supervised learning, unsupervised learning, and reinforcement learning can play a role there, for instance, for forecasting, for instance, for reducing the complexity or to interact with the real system. So we believe that introducing AI in the network is the right tool to make the network management more flexible. And as an example, now Andrés is going to present our solution for the AI management of the virtualized radio access network called vrAIn. So Andrés, you can start.
Okay, thank you very much, Marco. So I'm gonna start before going directly to the live video. I'm gonna provide a little bit of motivation of the concrete problem that we are targeting here with this work, and a little bit of the vision of the architecture of the solution that you're gonna see during the live video later on. So the problem that we're handling here is resource control. It's a classic resource control problem in the context of virtualized radio access networks. Okay, so why do we care at all about virtualized radio access networks? Here we built a couple of slides to actually motivate the needs for this, and why a lot of manufacturers and operators are very interested in this type of technology. Right, so the typical view of open and virtualized RAN is something that like you can see on the screen, where you have at the edge, you have a cloud infrastructure where multiple instances of virtualized base stations are sharing common infrastructure, common computing resources, right? And the first advantage out of this approach is, it's very intuitive by everyone at this point, right? While by centralizing most of the radio stacks into common, computing infrastructure, you can exploit better statistical multiplexing, so you gain statistical multiplexing gains from resource pooling by centralizing all these instances, right? The second advantage is by actually making most of the base station stack in software, you can virtualize. You can actually, import some of the healthy software or approaches from the software development world, like quick roll-ups of security patches, protocol upgrades, bug fixes, continuous integration, continuous development. A series of approaches that have been implemented in the software development world for many other applications, right? But they have been very slow into being, integrated into the mobile network ecosystem. Okay. And this comes from, the softwareization of the base station. And the third advantage, and probably the most important one, and that comes with a standardization of open interfaces between the different components of the base station, come from what we call commoditization, right? So by opening or specifying, standardizing the interfaces between the different components, we can move from traditional radio access networks where all the components belong to the same manufacturer, to a situation where the radio access network is comprised by multiple manufacturers which are competing, right, for the same market, and this, as we all know, foster innovation and also reduce costs. Okay, so we are targeting here a specific problem in this system which is the allocation or the orchestration of resources to each individual instance of virtual base station. Okay, and I'm gonna first show you a set of experiments that we ran offline before we go to the live video, just to show you or demonstrate why this problem is complex to solve, and why we need deep learning or artificial intelligence to solve this problem, right? Why we just don't apply any simple heuristic or any other traditional solution, right? So the plot that you can see on the screen, well, it's a heat map. It's an experiment we ran in the lab with a virtualized base station using SSLT in this case. So the base station is running on a Docker container. It's a fully fledged release 10 compliant LTE stack running in a Docker container, and the user is just a regular smartphone. And in this experiment, we are sending in the uplink as much traffic as we can towards the base station. Okay. In the y-axis, we are changing the modulation coding scheme used for communication. And in the x-axis, what we're changing is the amount of computing resources that we allocate to the virtual base station. Okay, and the different colors reflect different throughput performance. Okay, yellow color means we achieve the maximum theoretical throughput we should achieve, and in the system. And as we go towards more bluish colors, so you will reduce throughput relative to that value. So the first, I mean, this plot doesn't really show anything very striking or very counterintuitive, right? Specifically, if you reduce the modulation coding scheme used for communication, all people that have some knowledge on ready fundamentals know that we will reduce also the throughput, right? Because we are packing less bits per unit of time. If we move on towards the left, in the x-axis here, as we reduce the amount of computing allocation in the base station, there is a boundary that you can easily identify here, from which we achieve zero throughput. And this is also very intuitive, right? So higher modulations require higher computing resources, and when we don't provide sufficient computing resources to this base station, given the modulation coding scheme used for communication, right? Essentially, the base station cannot proceed all this traffic and disconnects, okay, and you get zero throughput. And you actually see a very nice linear pattern here, which can be easily fit with linear models. Nothing fancy here. The problem comes when we change the context. And by context, I mean, the channel conditions, but I also mean the computing platform where we are hosting the virtualized instance of the base stations, or even the applications running on using the base station, right? The different load patterns that we see over time. So in this experiment here, what I'm running exactly the same experiment, but I'm changing for the different columns of this plot the average channel conditions, from the very good channel conditions that we had in the earlier plot to medium channel conditions and very poor channel conditions. And the difference between the three plots at the top and the three subplots at the bottom is that we change the compute infrastructure. Okay, these both are actual off-the-shelf laptops, but just different laptops. Okay, and what you can clearly see without the need to go into details of the different colors and the rationale behind them, what you can see is that when we change the channel quality, the context around the location of the users towards the base station, you see that this clear blue boundary that differentiates between you have enough computing resources or not, is not so linear anymore. It's not so evident anymore. What's more, if you just change the type of computing infrastructure, the patterns substantially change. Okay, this makes it really hard for traditional models to fit, because you would have to be recalibrating over and over again. Same in this plot, instead of changing the channel conditions, what I'm changing is the load patterns, okay? From very low load, 10% of the critical load, to high load. And what you can see here is that this is even harder to predict, or the linearity that we saw in the first plot, completely vanishes here, particularly when we are in low load regimes. So without going into details of these plots, we can discuss later if you want. Here, the actual conclusion that I would like to get at with these offline experiments is that, the problem of finding out the appropriate amount of computing resources that you need given a certain context is not easy to capture with traditional models. And therefore, what we resort to here is with deep learning. as Marco Gramaglia introduced at the beginning of the presentation. Okay, so our system goes as follows. What you're going to see later goes as follows. Here we have a system that collects continuously monitoring information from the base stations. Okay, specifically, we collect both radio signal quality samples from all the base stations in the system. In this case, we will have 2 in the demo, 1 or 2, depending on the use case that I will show you, over time across all the users attached to these base stations. And we also collect information about the buffer states of the base stations and across all the users attached to those base stations over time. What we do here is we put this information and we actually feed our kind of reinforcement learning engine, which we call here Resource Manager. Here, I'm not going to spend a lot of details about how we actually constructed the neural networks inside this Resource Manager, but just to tell you that this is just not a simple deep neural network that we introduce here. It's a little bit more elaborate than that, and I will be happy to discuss with you later about the details of this construct. And as a result of this, what this Resource Manager does essentially is maps the context information that we collect every now and then, right, into a pair of policies. Okay, one is a computing control policy, the other one is a radio control policy. Okay, specifically for the computing control policy, we actually set some upper bound shares of computing that we implement using Docker API. This is actually a standard computing control policy that Docker enables for any. And for radio control policy, what we do is a minor change to the MAC scheduler of the base station here, and the policy consists on an upper bound on the modulation scheme that is eligible by the MAC scheduler. This means that if a base station has very good channel conditions, or if a wireless link between a user and a base station has very good wireless conditions, such that the user could actually use very high modulation schemes to send more bits per second, our vrAIn, our resource manager, can actually impose an upper bound on that modulation scheme because maybe there is no enough computing capacity at the moment to satisfy that the demodulation decoding of such high modulation coding schemes. Okay. Then, of course, we then implement the classic reinforcement learning closed loop model, where we collect, performance indicators. We translate these numbers into an actual reward and a score to see how we are doing, to see how well we do the mapping between context and control policies. And when we do training, we close the loop by retraining the neural networks that comprise the resource manager. This is essentially the architectural picture of the system that we are going to demonstrate. So if there's no question so far, I will move straight to the actual live demo of this thing. Okay, so just 1 second. Okay, so here what we're going to demonstrate is 3 use cases. In the first use case, we only have 1 virtual base station, and our objective is to actually minimize costs in the sense that we minimize the allocation of computing resources while we satisfy at the same time certain quality of experience targets. Okay, and in the second and third use case, we'll have 2 virtual base stations sharing the same computing platform, actually sharing 1 single CPU. So we have deficit of computing capacity. So 1 single CPU core is not enough to satisfy the demand of 2 virtualized base stations when they are at full load. And we will see how vrAIn adapts to these scenarios. So in the first case, as I said, I'm going to first start with just 1 virtual base station. I'm going to start the demo. So, so the setup, we have it in the premises of FuseTM. So what is happening right now is we are bringing up the Docker container with the virtualized base station. We are actually bringing up the virtual UI. We are using actual wireless channel. So this is a real wireless communication, okay? And now the UI has connected, and we are supposed to have connectivity. And this is what I'm going to show you later on. Here at the bottom, we have a set of kind of knobs that we can fine tune as on demand, right? So this Q parameter here is sort of the quality of service priority or target that we want to impose into this virtual base station. In this case, we only have one. So here we have normalized the number just to make it easy, where 1 means actually we want to prioritize performance over consumption of resources. And 0 means that we want to save as much computing resources as possible, even if we need to sacrifice performance by doing so. Transmission power here is just our means to emulate different distances from the UE to the base station. Higher transmission power means we are close to the base station, we have good channel conditions. A value of 0 means that we are far away from the base station, we have poorer channel conditions. And here we are actually emulating some synthetic traffic load. We are generating load following a synthetic but dynamic traffic pattern that I will show you in a second. But we can, of course, change it to static and put any value that we want on demand. So this is the dashboard or the monitoring dashboard that we have implemented to keep track of all the performance indicators, the different policies to identify what's going on in the network. There are many plots. Let me try to identify the most important ones right now. So at the top, we have actually a measure of the energy or computing savings that we have at the moment, which means, okay, out of the capacity that we have in the system, vrAIn is allocating less resources than the full capacity, which means that we are saving computational resources, and that is reflected by the purple plotting here. The blue plot, the blue line also only shows the actual system reward at this moment, which is very high at this point in time. And both of them are normalized between 0 and 100%. Then at the bottom, we have different performance metrics for the different base stations, virtualized base stations that we have in the system. At the moment, we only have one base station, so that's why you only see things moving at the left-hand side, which is the performance metrics associated with this first base station, right? So here, what you can see, for example, is that the channel conditions are very good. We set the transmission power very high value. We can of course change it to different values as we want. We have the bit error rate of this base station, which is currently 0. And vrAIn, the most important target for vrAIn is to maintain consistently 0% bit error rate. Okay, this is a very important target for our reinforcement learning logic. And the other 3 plots are both performance and policy measurements. The first plot here is a dashboard or a plot to show the current radio policy. Okay, this is the actual green line here. What you can see here, the policy is measuring modulation encoding scheme index, and goes between 0 and 22, which is the highest modulation encoding scheme that we could use in the uplink in this case. What you can see is at the moment, vrAIn is assigning the highest modulation encoding scheme as a policy, which essentially means that vrAIn is not constraining the eligible modulation encoding scheme that this base station can use at this moment. And because we have high channel conditions or very good channel conditions, the green line, which is the actual modulation encoding scheme selected by the radio scheduler of the base station, is also using accordingly high modulation encoding scheme. And this is translated into high throughput. And this is what you can see at the bottom slide. In the bottom slide, on the one hand side, you see in green the actual demand, low demand, what the user generates in the uplink, and in green, what you see is the actual throughput performance. Okay, essentially what you see here is because we have good channel conditions and we haven't imposed any constraint on the radio policies on the base station, we're using high modulation schemes, and therefore we satisfy all the demand. To do the same, what we saw in the middle plot is actually the computing allocation-related metrics. As we did before, in yellow, what you can see is the actual CPU consumption of the base station, which of course follows more or less nicely the load demand patterns. Evidently, higher load implies higher network load implies also higher computing load in this very simple case. And what you can see, which is more important, is that vrAIn assigns computing policies, so upper bound on orchestrate computing resources following these patterns. Okay, of course, given some sort of margin between the actual demand and the actual resources, because we have tuned our system to favor performance over computing utilization. Okay, and therefore vrAIn, in order to do that, okay, it trades off between being conservative in the allocation of resources and assigning the whole capacity of the system to the base station. Okay. So let me try to move back to my dashboard. Of course, we can change many things here, right? If we actually increase this value here, which essentially means that I'm going to favor performance over computing allocation, and I click on set, what's going to happen is that you will see a bump in the computing allocation assigned by vRAIn to the base station. This is more evident, as you can see now, right? This is particularly evident when the load is low. vRAIn is assigning overly high computing allocations, just to ensure that the base station will have high performance regardless what happens, regardless the future dynamics of the system. Okay. What's probably more interesting to see is what happens if I actually favor, savings in computing allocations over performance. And this I do by clicking here. What we will see in a second is that vRAIn will be way more aggressive in the allocation of computing resources, as you can see here now. You see that the margin between the actual demand of computing resources and the actual allocation is very small now. More importantly, it's below even the computational demand that the base station needed in some cases before. Now, to do this, particularly when the load of the system is high, vRAIn is actually reducing the radio policies on the base station, because in order to be overly aggressive in the allocation of computing resources, in order to save and squeeze as much as vRAIN can in terms of computing resources, we also have to sacrifice performance. And vRAIN understands that by actually imposing restrictions on the eligible modulation coding schemes by the base station. Okay, because lower modulation coding schemes, when the load is high, right, require less computer resources. And this is how vRAIN actually can, move across the trade-off between performance and computing savings. Now, and vRAIN or the system is unique in doing so. Okay, if we had a system where it didn't impose any policy on the radio scheduler of the base station, the system will just break, given this small computing capacity. Okay, I'm gonna demonstrate this by actually liberating the base station from obeying the radio policy imposed by vRAIN. Clicking here, what you will see is because the base station is enjoying of good channel conditions, the radio scheduler can actually select, and does select now, high modulation encoding scheme indexes, way above the actual limit or boundary imposed by vRAIN. What you will see is that this, particularly when the load of the station is high, this translates into there is not enough computing capacity to serve this amount of load at high modulation encoding scheme, and as a result, we have very high bit error rates because we cannot process the physical layers of frames with this high modulation scheme, and the system just breaks. Now the user completely disconnected from the base station. That's why you don't even see measurements of signal to noise rate. Gonna go back to vRAIN, and at some point here we are trying to reconnect the UE all the time. Hopefully it will happen soon. So this was essentially the first use case that I wanted to demonstrate. Is there any questions so far? I don't know, Carlos, how do you want to handle questions here? Because we're a lot of people.
In the chat. So if there are any questions, we need to get the questions through the chat.
I can't hear you.
If somebody else wants to make a question at any time, please put it in the chat, and then I will let you know.
Okay, I cannot hear Carlos. I'm not sure if there's any problem. Otherwise, I will just proceed.
Can you hear me now? Can you hear me?
Okay, so now the case that I'm gonna turn this off now. Okay, for some reason I cannot hear anybody. I don't know if it's because I have the mic open myself. So we'll move on to the second use case. In the second use case, I'm going to have actually two virtual base stations running on the same CPU core. So essentially, we're going to have two Docker instances with two on different instances of base stations running on the same single CPU core, which is typically not enough computing capacity to serve both base stations at full traffic. I'm going to turn on, and what you can see now here is that you see two kind of sets of knobs. So we can actually change the different configurations for each individual base station. So now I'm essentially bringing up the Docker containers and bringing up the actual UIs, and I'm connecting them to the virtual base station. Okay, they're connecting now. And here by default, we are actually showing the same load patterns that they showed before for one base station. We can, of course, change it on demand, but essentially the context and dynamics of both base stations are now identical. Let's wait a little bit till it moves on. Okay, what's happening now is that, so the green line here at the bottom is the actual demand for load of base station 1 in this case and base station 2 in this other case. Here in the right hand side we don't see yellow because we don't have a new real UI attached to the second base station, and therefore we cannot measure its throughput. Okay, but we do have the real base station instantiated on the CPU core. But what's happening here is that when both base stations, the load of both base stations peak, there is not enough computing capacity, right? Now vRAIn, because both base stations have identical context and the configuration are essentially the same across both base stations, can only assign equally 50% the amount of computing capacity that we have in the system. As you can see in the middle plot here, vRAIN assigns roughly 50% to each of the base stations. The problem is that with load, one base station requires more than 50% of the computing capacity to serve all that traffic. So what vRAIN does in order to actually accommodate these two virtual base stations with such an under dimension computing capacity is to impose, as you can see here at the top, radio control policies that are well below the the modulation scheme that the base station could use given the good channel conditions. Here, both base stations have good channel conditions. So when both base stations peak, right, vRAIN is essentially assigning lower modulation coordinate schemes suitable to actually fit both base stations in the same CPU core. Okay, and this happens over and over again. Like I did before, if here in this situation where we have underdimensioned computing capacity because we want to save capex capital cost or for any other reason, we just had legacy base stations that do not obey any radio policy from an upper layer orchestrator. What's happening, and this is what I'm going to demonstrate now, is that the base stations or the system cannot actually satisfy the demand when both base stations peak at the same time. You will see when both base stations reach the peak demand, since the base stations, the schedulers will not obey the policy imposed by vRAIN, you will see that the computational demand exceeds the capacity that they have, and therefore the base station will just break. This will happen now that we're moving towards the peak load. Now what happened is that the computational demand of the system, because it's using high modulation coordinate schemes, exceeded the limit that we have on computing capacity. As a result, the base station is actually suffering a very high rate of bit error rates, a very high number of bit error rate, and the UI just disconnects. Why? Because we don't have enough computing capacity at the moment, and we are not imposing any restriction to the actual radio performance to alleviate this demand of computational capacity. I'm going to go back to vRAIN. Let's wait a couple of seconds till the UIs reconnect. actually, let me turn it off and on again. So this bit error rate metric is actually one of the most important metrics here. It's at the center of this dashboard, is because vrAIn targets, or the most important target of vrAIn is to keep bit error rate to 0. Bit error rate coming from, because you have poor channel conditions using an overly high modulation scheme, or, and this is the new thing, bit error rate or bit errors coming because you don't have enough computing capacity to process subframes at the physical layer in your computing platform. Okay, so we are back online. So what I can demonstrate now is the third use case, which is essentially, we have the ability to assign different priorities across the multiple base stations that virtual base stations that we may have in the system. So just to demonstrate this, so here, as you can see in our dashboard, we have this Q value, where 1, as I mentioned before, is where a situation where we favor performance over computing computational demand or computing allocations, and vice versa, right? So here in the first case, what I can do is, for example, assign a quality of service priority to the base station 1 to 0, which means that we're going to sacrifice performance here over computational capacity. And in base station 2, I'm going to favor performance. I'm going to set here, I'm going to set here. And hopefully we will see the change in this base station, in this monitoring dashboard. Here, what just happened, what you can see here in the left-hand side is that the vrAIn is assigning less computing capacity to base station 1, and shifted this computing capacity to base station 2. Okay. Of course, what's the problem by doing this? Now in base station 1 we are even lower computational capacity than we did before. This actually results in vrAIn assigning even more restrictive radio policies to the base station. So we are sure that the base station doesn't run bit errors when processing physical layer subframes, right? To maintain or keep in control the computational demand of this base station below the limit that vrAIn as well is imposing here. Of course, the throughput performance of this base station is heavily sacrificed. In exchange for this, what we have here in the right-hand side is that now vrAIn is assigning high radio policy to station 2. Okay, this should result in actually higher performance, throughbut performance to this base station as a result. And we can do this because now we are assigning higher computational computing resources to base station 2, thanks to the sacrifice of base station 1. I'm going to reverse the configuration so you see this effect here. So now instead of having this very low priority base station 1 and high priority in base station 2, I'm going to have very high priority, quality of service priority in base station 1 and very poor priority in base station 2. So essentially, this excess of capacity that we assigned to base station 2 now is going to vanish, and it's going to move to base station 1 instead, what you just saw now. Now base station 1 or vrAIn is assigning much higher computational capacity to base station 1, thanks to the sacrifice that base station 2 is doing here, which is allocated lower computational capacity. As a result, the same story as I explained earlier, right? Base station is actually, or vrAIn is assigning much lower radio policies in base station 2, which results in the performance penalties that we saw earlier. But now base station 1 can actually enjoy of higher modulation point schemes that is still within the computational capacity limit imposed by vrAIn. This result into much higher throughput performance than earlier, right? So essentially here in this third use case, just to demonstrate a case where, for example, we have an edge cloud provider, and the third parties are operators or virtual operators that want to deploy the virtual instance of the base station in my edge cloud, and we can assign different prices, right, depending on the trade-off between performance and computing capacity that you assign. And we can play as much as we want with these prices and these kind of trade-offs that we want to assign. importantly, regardless how we play with computational capacity, we to the station, the radio conditions, the platform, doesn't matter the context, vRAIn will keep learning, right? We'll keep learning, and we will ensure that regardless the context that we have, the bit error rate of the base station will be 0, while we maximize, or we try to maximize, the throughput performance given the context that we have. If we're in a situation where we have an extreme deficit of computational capacity, then of course you will have low throughput, right? But you will have throughput, you will have connectivity, you will vRAIn is maximizing the throughput performance that you could ever get given the constraints that the system have. Okay, and this cannot be achieved if you do not optimize jointly the radio allocation policies, the radio control policies, and the computing allocation policies. Both of them are difficult, and therefore they have to be optimized jointly, as we demonstrated here with vRAIn. This essentially finalizes my demonstration. So I'm happy to answer questions.
Okay, thank you very much, Andres. So one question in the chat. So either you or Marco can address it. It's about. I guess you can read it from the chat.
Yeah. So I can take that then. Of course, Andres, you can add on my answer. So the question is, can you extend the framework to account for varying energy prices, greener energy, or etc., and favor using CPU resources with cheap electricity over ones with expensive? So the answer is yes, but this requires an additional orchestration framework on top of our solution. Basically, our metrics, as Andres was discussing before, take into account the resource consumption in terms of CPU and the quality of services given by basically the bit error rate. So if you want to balance over different prices, you need to have an orchestration algorithm tops that then deploys our solution where the energy is cheaper. But if you can do that, then our algorithm, our solution through AI can get the most out of it. Basically, vRAIn is a short-term orchestrator, fast orchestration that operates at seconds granularity, while this kind of fluctuation of energy prices are usually slower, so you need to tackle them at a different level in the network.
Okay, thank you, Marco. Thank you very much. I think Andres has some issue, but rejoin. I don't know if Andres wants to complement or anything. Otherwise, since we are just on the agenda time, we can maybe move on to the next one.
Yeah, basically, if you have any further question, you can just drop us an email either to me or to Andres, and we'll be glad to answer.
Okay, thank you very much. Thank you, guys. So then, I guess the next one is Carlos Guimaraes. So, Carlos.
I can, let me share my screen. So I think you can see the slides. I mean, it's the first time that I'm presenting this platform, so I'm not.
We cannot see them yet.
Okay, now you should be able to see. Okay, thank you. So good morning. Just to introduce myself, so my name is Carlos Guimaraes. I'm a postdoc researcher at UCTM working on the 5G DIVE project. Today I will briefly present the platform, which stands for 5G DIVE Elastic Edge. And this is the scope of 5G DIVE project. So this is the outline of this presentation. So I will go very quickly on this. So I will present an overview on the platform. Then I will present an integration example with 5G Coral platform. which is a distributed edge and fog computing platform that was developed under the 5G Coral project. And then I will conclude by mentioning the vertical pilots and the use cases that are targeted in the 5G Dive project. So the goal of the DEEP platform is to support the vertical industries in day-by-day operations management and automation of the business processes on top of an edge and fog infrastructure. And in other words, this means that it's to ease the verticals on developing, running, managing their services, abstracted from the complexity of dealing with a distributed environment, such as the one that we can witness in an edge and fog environment. And at the same time, it aims at providing a set of services to support enhanced business automation and the provisioning of intelligence capabilities. So the DEEP platform, which is shown here in this figure, has been designed considering a set of design principles. So the first one was to move from an infrastructure as a service towards a platform as a service model, in such a way that it could allow a vertical focus on the service logic and its requirements, while being abstracted from the complexity associated to an edge and fog computing infrastructure. The second one was to follow an add-on based approach, in the sense that it provides a set of additional functionalities and services to the verticals, while still allowing their legacy interactions with infrastructure. The third one is that this platform should be platform agnostic, meaning that it must be flexible to be integrated with different edge computing platforms. And finally, it should consider automation and AI, so it can enable the automation of the business processes and to simplify the provisioning of artificial intelligence and machine learning based capabilities. So the DEEP platform is composed by three main building blocks, which we called here support strata. So on the top of the DEEP platform, we have the business automation support stratum, the bus, and the bus consists as the logical entry point for the verticals or vertical service management, while offering required support for automation of the vertical business processes. And this includes several functionalities, such as translate the vertical service descriptors that are provided by the vertical into a number of network service descriptors, to set up the required automation mechanisms to guarantee that the vertical service SLAs and policies are met, and also to ease the alienation of resources belonging to the vertical that could be leveraged for the deployment of the requested vertical service. Then on the bottom left part of the DEEP, we have the data analytics support stratum, the DAS, and the DAS offers the required support for gathering, preprocessing, storage, and sharing of data generated from the vertical service. From the vertical service operation, and this includes functionalities, and it is somehow implied, such as gathering data from different sources and distributing it to all the interested parties. And in the process, data preprocessing can be applied, such as filtering, normalization, anonymization, transformation, etc. And also, this data can be stored for future usage. And then on the bottom right part of the DEEP, we have the intelligence engine support stratum, the IESS. And the IESS offers the required support for the provisioning of AI and machine learning based capabilities. And this includes functionalities such as selecting the best AI machine learning model based on a given intent, and also for training this model and to cross-validation the model. Then, as the DEEP is placed as an add-on between the vertical and its OSS and DSS systems and the edge computing infrastructure, it requires several interfaces to interact with each one of these blocks. So, namely, we define a set of interfaces towards the vertical and its OSS DSS systems for operations related to the vertical service management, for operations related to the collection of context information regarding the vertical services that are provided by the vertical, and this information can be leveraged for the business automation and also for training a specific AI or machine learning application. And also we have interfaces that allows operations related to the notification or requests for actions when the DEEP platform is not able to provide the automation or is not able to guarantee that a given SLA or policy is fulfilled. And then we have also interfaces towards edge computing infrastructure, namely for operations related with onboarding, lifecycle management, and monitoring of the network services, and also for collecting information from virtual network functions, from the virtualization infrastructure, and also context information regarding the edge computing infrastructure. Okay, so now we are going to see an integration example of the DEEP platform with the 5G Coral platform, which, as I mentioned, is the distributed edge and fog computing platform. I will not enter into details of these integrations because of time constraints, but instead I will present some of the integration guidelines that were followed. So the first one was to provide the DEEP as an add-on on top of 5G Coral. And this matches one of the design principles of the DEEP. And the goal is twofold. So the first one is to enable the verticals with a fine-grained control over the infrastructure where its services are deployed. And the second one is to enable a transition period towards the use of the DEEP platform. Then the second integration guideline is the use of standardized or existing interfaces that are made available by the 5G Coral platform. And this aims to leverage as much as possible the DEEP to interact with Coral, requiring any changes on the 5G Coral components. Then the third guideline is that data is key for automation and intelligence. And here, the automation of the business processes and the provisioning of intelligence applications is highly dependent on the amount of data and the quality of the data. So the DEEP must be able to collect data from the different entities, from the different EFS entities, and also from the virtualization infrastructure. And this information here can be collected from the 5G Coral platform by interfacing with the EFS service platform. Then finally, the final one is that this integration needs to ensure a control loop stability, in the sense that each one of the building blocks can take decisions on its own, and therefore it is important to enforce mechanisms that ensure a stable control loop through the whole system. So this integration between the DEEP and the 5G Coral platforms is going to be leveraged in the 5G type project to validate an intelligent 5G solution that integrates 5G connectivity with edge and fog computing. And this validation is going to target trials in relevant industry segments, namely on the manufacturing segment, focusing on Industry 4.0 scenarios. And here, three use cases are going to be addressed: the digital twin applications, augmented zero-defect manufacturing, and massive machine-type communication. And then in the public safety segment, focusing on autonomous drone scouting, two use cases are going to be addressed: drone fleet navigation and intelligent image processing for drones. So I will not enter into details of each one of these use cases, as Antonio already presented them in the first session. And also because in the following presentations, we are going to see some mini demonstrations of two of these use cases. So with this, I close this presentation. Thank you for your attention. I don't know if there is any question.
Thank you, Carlos. I think we should move into Milan presentation.
Okay. Okay,
so, Antonio, you're gonna share the presentation?
Yeah, I'm on it.
Okay.
Not sure if you can. Can you see it properly?
Yes, yes, we can.
Okay.
At least.
So just tell me, because I'm full screen with the slides. So just tell me.
Okay. Okay. Hi everybody. My name is Milan Groshev. I'm a PhD student at UC3M, and I'm gonna present to you one of the use cases that we have. That is the digital twin applications in the 5G Type project. Precisely the assessing the need for 5G for the digital twin applications. We can move on to the next slide. Thank you. So in general, when we talk about digital twins, we talk about virtual models of physical objects that are created in digital way to simulate their behavior in real world environments. So the digital twin is composed mainly of three components: that is physical entity in physical world, virtual models in the virtual world, and then there is the data that connects these two worlds together. The data from the physical world is transmitted to the virtual model using sensors, and the simulated data is fed back to the physical world in order to respond to changes, improve operation, and increase value. As such, these digital twin applications come with several requirements that are mainly connected to the data that ties these two worlds together. A low latency data between the physical objects and the virtual models can give us a real-time control system that is able to perform fast reaction to unpredictable events or environmental changes. Moreover, in industrial automation, physical objects start to interact more and more with humans, and the human proximity means much more stricter requirements for safety, and this indicates that these types of applications are also very sensitive to data losses. It's also true that as we increase the number of physical objects, we can get a better representation of the real world environment, but also it means that it requires much more bandwidth. And finally, availability is a very key important concept here that is crucial to have a fully functional system. We can proceed. Thank you. So the implementation of such applications like digital twin nowadays are done mostly in the cloud, with the powerful computing capabilities, scalability, and also virtual services that are offered by the cloud. It provides an efficient manner for massive data processing, storage, and also satisfies the demand for large-scale collaborations. Like this, digital twin systems are becoming more interoperable, smart, adaptable, and distributed. By using the cloud, manufacturers and users are freed from many details related to infrastructure management, but also by using the cloud, it can offer high quality of service at lower cost. The data sharing also between virtual models is possible. Since the virtual world is now placed in the cloud, this means that virtual models can exchange information about their current operations, and they can improve also their coordinated operation. So, however, as such, today's cloud-based digital twin application have some limitations. First of all, the data that connects these both worlds is stored in the cloud, and it can be accessed in any time, but users rely heavily on the availability of internet connection and the servers. When the data cannot be accessed due to network unavailability, the power of the cloud becomes unusable. Moreover, the unpredictable underlying network between the physical objects and the cloud may suffer from network congestion and wireless interferences, introducing increased latency, unpredictable, limited bandwidth access. As a result, time-sensitive computation requirements are very difficult to fulfill in such cloud digital twins. These time-sensitive computation modules for that are envisioned to be on board in the physical objects, and this increases the price of the physical objects by requiring high-frequency CPUs and RAM memory. Moreover, the integration between private manufacturing systems and public clouds raises a set of privacy and security concerns that include data and computation outsourcing, access control, and also multi-tenancy. And finally, the data generated by the sensor also may be inaccurate, incomplete, inconsistent, or even duplicate. That will give us a fake representation of the reality. So new algorithms are needed for efficient data filtering and sampling in order to prevent failures. So what is the approach that we take in 5G DIVE in order to address these limitations of today cloud-based digital twin applications? If you can go, Antonio, one slide back. Back. Okay, thank you. So we involve mainly two pillars into the picture. That is the edge and fog computing and also the 5G connectivity. Edge and fog computing has gained some attention from the industry and also academia in the recent years, and as such can bring some advantages to digital twin applications. First of all, characterized by the proximity and that is close to the devices, digital twin applications can obtain real-time information for the radio network condition. Based on this information, we can adapt the physical object operations or also try to optimize the network in order to improve user experience. The edge and fog are also very well positioned to overcome the real-time constraints of cloud-based solutions. By placing the time-sensitive computation modules in the edge of the network, we can ensure high computation capabilities while leveraging the low latency communication and the high bandwidth. Also, distribution of computational and data needs can be done now across different tiers. So the non-time sensitive processing, let's say, can be done in the cloud, while the time sensitive and the data filtering can be performed in the edge and the fog. And finally, security and privacy can be also improved by offering restricted access of the data inside the trusted private domain. The second pillar of our approach is the 5G connectivity. We've seen the requirements of digital twins applications among wireless technologies. In this moment, we think that 5G is the technology that has the potential to satisfy these tight requirements. In industrial application, where the overall end-to-end latency budget is spent mostly on data processing received from the sensor, the remaining part of the latency budget is to communication. It's limited to a few milliseconds, and it requires guaranteed reliability and also high bandwidth. Okay, so let's take a look at our demonstration setup for today. So we have the physical world that is represented by our robot manipulator, and we have the that is composed of mainly three components. So the first component is the controller. I'm listening to an echo. I can hear my own voice somehow. Okay, it's the controller that is basically connected to a joystick, where the user can execute commands. This controller module is in charge of getting the commands executed by the user and translating them into robot joint movement commands. Once he translates these robot joint movement commands, he executes into the motion planning module. The motion planning module is getting the current pose of the robot and tries to see if the wanted movement is possible by the physics manipulator. If it's possible, in that case, it executes the movement of the robot, and with that causes the robot to change the position. Once the robot starts to move, the state publisher updates the robot pose to the digital twin and is in charge basically in keeping tight synchronization between the physical world and the virtual world. Okay, Antonio, we can move to the next slide. Okay, this is the steps that I just described, the controller with yes, as you can move, okay, the demonstration. Perfect. So our demonstration was initially envisioned to be performed using the two pillars that I just mentioned, that is the agent for computing and also the 5G connectivity. However, due to the COVID situation and the limited access that we had to our laboratory this whole period, we were not able to perform it over 5G. In the meantime, for this workshop, we decided to evaluate the performance of digital twin applications over wired and wireless medium under different network conditions. For wired medium, we chose Ethernet, and in that case, we assumed stable network conditions. While for wireless medium, we selected Wi-Fi, and as we know, 802.11 technologies are time variant, and they can be affected a lot by different radio frequency interferences. To that end, we decided to introduce artificial delay and artificial packet loss in the Wi-Fi scenarios, and we performed that from the robot towards the virtual model that we consider as an uplink, and from the virtual model towards the robot that we consider as a downlink. So without further ado, I think we can proceed to the video of the demonstration. Okay, so this is the first scenario over the Ethernet. In this scenario, we can notice that we have the robot manipulator that is representing the physical world, and the remote controller with a digital twin that is representing the virtual world. In this case, the remote controller is using a joystick and a digital twin to perform a given task. We can notice that as the remote controller is executing commands in the joystick, they are being transferred and executed in real time on the physical object. The network conditions are good, and this gives him the needed precision to execute the task. Additionally, the state of all the robot joints are transmitted in real time from the robot to the twin, and we can notice that the virtual model of the robot is being updated in real time. This enables the user to have real-time representation. 1 second, Antonio, is it the video blocked or is it only for me blocked? Can you hear me? Can you hear me, guys? Because I cannot hear you. I don't know what.
Yes, we can hear you. And the video now was moving.
From my side, I haven't seen any stop.
Because for me, it was quite blocked and glitchy. Now it's okay?
Go ahead, Milan, continue.
Okay. So basically, we have in this case we have a tight coordination between the physical world and the virtual world, and this enables the user to perform the wanted task. In the other side, this data is kind of reliable, and we can use it in the virtual world to store it and perform operations later on. Now let's take a look at the latency effects that can have in digital twin applications. The increased uplink latency makes the remote controller to operate on delayed data. If we focus on the digital twin, we can notice that the physical objects and the virtual model are not synchronized. This can cause a problem if we need a real-time reaction from the user when he needs to operate on the digital twin. The increased latency in downlink, in the other sense, it decreases the reaction time of the remote controller, and as a result, we are losing in precision. As we can notice in the video, this loss of precision is making difficulties for the user to execute the needed task. The downlink increased latency also can cause a burst of delayed packets. This will make a set of commands to be buffered and later on executed in a sequence, giving us an unpredictable and unwanted behavior like the one that we saw in the video. The last is the packet loss effects in digital twin applications. Now, digital twin applications in downlink, when they experience packet loss, it can make very difficult for the remote controller to control the physical object. If we focus on the remote controller, we can notice that he is trying to execute commands on the remote manipulator, but our physical object is not reacting. The user tries to adapt to the situation and tries to navigate the robot, but as much as he tries, he is getting an unpredictable and uncontrolled movements from the robot manipulator. And these unpredictable and uncontrolled movements are making the whole environment unsafe for operation. He tries to control the robot, but the robot is not following the commands. Lastly, suffering from uplink packet loss, we can notice glitches in the digital twin. The remote controller will have difficulties when he needs to operate on such a virtual model. And in addition, this data is unreliable and very difficult to make predictions on in order to improve operations. Now for the last slide regarding the conclusions. If we so as we've seen, latency and reliability play a big role in digital twin applications. Wired medium, such as Ethernet, can provide sufficient values in terms of bandwidth, latency, and reliability. But once we move into the wireless domain, then we start to face certain limitations. Latency effects can cause us to operate on delayed data. Latency effects can decrease the reaction time, and they can also decrease the precision. Moreover, packet loss effects makes it difficult to manipulate the physical objects, makes unpredictable and uncontrolled movements, also can cause glitches in the virtual world, and can cause us to operate on unreliable data that is very hard and difficult to make any kind of optimization or predictions based on that data. So in the near future, we hope to test our 5G system and to manage it, to configure it in a certain way that we are able to satisfy the required values for digital twin applications. Thank you very much for your attention, and if there are any questions.
Carlos?
Yes, I think there's one question from Chi. So the question is that, do you think that using 5G can overcome these effects of other technologies?
Yes, we believe so that we will be able to overcome some of the effects, at least for sure, regarding the latencies and regarding the bandwidth. And we already in 5G type, there were some initial results and testing regarding the 5G system that were performed, and we believe that we are going to be able to overcome.
Okay, thanks a lot. So then, Antonio, I think we have one more video of a demo from 5G Dive, right?
Yeah, most probably the audience doesn't know, but 5G Dive is a Europe-Taiwan joint action. So the digital twin falls under the European side, while we have another application on drone scouting that falls in the Taiwan side. So NCTU, that is the National Chiao Tung University of Taiwan, has prepared a video of their current work on this aspect that I'm going to show right now. So give me 1 second. So you should be able to see the video. Can you see it?
Yes.
Perfect. And you should be able to listen to it. Okay, looks like we cannot hear you. I mean, we cannot hear the video. Carlos, any idea of how to overcome this?
Not really. I don't know if you can share a video, as you can share the PDF or, well, I think it's only image, PowerPoint or PDF. So no, I don't know how to. I don't know. Maybe you can explain a bit, or Timothy can explain a bit over the video what is happening.
Yeah, Timothy, you are. So
hello, can you hear me?
Yes, Timothy, we can.
So what I'll try to do is like I will could you rewind the video and I will try to narrate the video. Yeah.
It's been played right now.
In areas devastated by disasters, it becomes essential to be able to identify and locate people in need for help. Disaster relief agencies and military personnel can use drones to quickly gather information, allowing rescue teams to provide immediate aid. In this demo, we showcase our disaster relief solution, which is called Eagle-Eye. Eagle-Eye stands for Aerial Edge-Enabled Disaster Relief Response System. It is a decentralized and scalable system designed to leverage pervasive edge computing infrastructure to support for disaster relief teams. The novelty of our Eagle-Eye system lies in the utilization of drones to identify and locate for persons in need of help, or PIH, in a disaster-impacted area in real time. In our current implementation, we categorize PIH as a person who is holding and waving a flag. The workflow of Eagle-Eye is as follows. Drones in the field will transmit video and GPS location to the edge via the Radio Access Network, or RAN. At the edge, Eagle-Eye trains a detection algorithm in the DEEP platform and deploys containerized worker application in the EFS for inferencing. When PIH is found, Eagle-Eye retrieves its corresponding GPS location and makes it available to the disaster relief teams. In Eagle-Eye, PIH recognition is achieved by using two modules within each worker. First, the object detection module, and second, the PIH detection module. The object detection module is based on YOLO v3. It processes drone video feed as input and then outputs detection result for person and flag object. The PIH detection module is a custom algorithm that we made. It processes the person and flag object from previous module and outputs PIH information. This information contains the timestamp and the GPS location of PIH. The two previously described modules are the basic component that made up an entity that we call a worker node. In Eagle-Eye, the number of worker nodes can be scaled up or down according to their requirement. For the demonstration, we set up a RTMP server to simulate a drone feed in real world. We stream the video feed directly to the Eagle-Eye system running in our edge data center. In our test scenario for the demo, we have 4 actors spread across an area, 2 for PIH and another 2 for non-PIH. The location of the actors can be seen from the video. Here, the window on the top left is the drone video feed. The window on the top right is the Eagle-Eye output with one worker node active. We can see that the output of one worker is significantly lagging behind the drone video feed. Now, we add another worker, making it a total of 2 worker nodes active. We can see some performance improvement. It is better than single worker node, but still lagging behind. We can see that the drone is performing a panning movement now to search for object of interest. Even though there are persons who are walking around, Eagle-Eye will not detect them as PIH as they are not holding and waving a flag. Finally, when we increase the worker node to 6, now here we can see a real-time detection. The output of Eagle-Eye is no longer lagging behind and can keep up with the drone video feed. Note that our result here only shows a simulation for a single drone stream. Eagle-Eye can be easily scaled up to accommodate multiple drone video streams. Our experimental results show that Eagle-Eye can reduce the inference latency by up to 50%. For our future direction, we are extending the Eagle-Eye to support the deployment of autonomous drone fleet.
Thank you very much, Timothy.
Thank you very much. So, unless there is any question, I guess we can move on to the final panel. So let me quickly go to the slides. So here we are with the final panel. We are almost on time. So for the panel, we have the same participants that we had before. Let me just quickly check that all of them. No, I have to add some as participants so they can actually present. So what I do it, once we have a panel that will follow the same approach like before, like some questions for the panelists to address. I will, I want to let you know that we will be asking some simple questions during the panel using this tool for asking them. And we will also basically send by email a small survey that you can fill in online, an anonymous poll. So please, we will appreciate if you can respond to the questions, both the ones that we are going to do now online and the ones that we will send by email. That will help us improving this for future events like this. Okay, so the questions or the panel is about how to basically provide some experience about how to do 5G experimentation across multiple EU projects. So I put there some potential questions like which projects are you collaborating with in your actual project, which is the value of inter-project collaboration, and what are the main challenges that you have faced so far in your experience during this collaboration. So as before, we can start with Chi. So Chi, I know that you have some slides, but I'm not sure if in order to make this more interactive, the panel, if you use slides, if you can try to just focus on one, or if you can avoid even using slides, I think that would be best. So we can have, in addition to your actual initial presentation, some time for discussion with between the panelists and also with the attendees. So Chip, please go ahead. One second, I have to make you presenter, I guess. Where are you? See. Let me try. Okay, here you are. Sorry for that. Okay, so you are presenter now.
Okay, now. Okay, thank you. Yeah. We'll share my file. Can you see anything from my screen? Sorry.
Not yet.
Okay. Okay. Now?
Now, yes.
Do you see anything now? Okay. Sorry for a little bit delay of the technical problem. Yeah, I will just show this slide. So in the project for 5G Growth, we are mainly collaborating with 5G Eve and 5G vrAIn, two ICT 17 platforms. So this slide I just would like to show that the challenge I talked at the very beginning of the workshop, that the challenge we are facing about how to connect the non-public network, the vertical facilities with the public network. And in this case, we are dealing with how we connect with the ICT 17 platforms. So we are working on this challenging, and we are proposing different options for how to interact the different platforms. So in the vertical side, we have our 5G growth stack, which is managing the resources and services at the vertical premises. And then when they require a connection and service from the public network or ICT 17 platform, we envision these two layers of interaction. One is that for the 5G Eve platform, we are requesting services as vertical services, either an entire vertical service or a sub of the vertical services. So this following the portal provided by 5G Eve, are defining on experimental context of the services. And the other interaction we are exploring with the 5G vrAIn, especially the side from Avio in Portugal. We are requesting the services on the never slice level. So the side they're providing is providing exactly the never slice view. So we are exploring the interface, how to request a never slice service from the 5G vrAIn platform. In addition, we also exploring interaction on the substrate layer, which is in 5G Eve is the interworking layer to interact with our cell orchestrator at the 5G growth side. With this interaction, we try to enable the our 5G growth stack can make its own orchestration decision about any resources and services in the vertical premises, while providing feedback about the monitoring as well. Lifecycle management for back to the 5G to provide end-to-end service management. So this is the overall slide I would like to highlight, and maybe final words for the project collaboration with two ICT17 platform. The value we have learned is that we are able to do large-scale experiment over full-fledged 5G network, including radio, transport, and core, as well as the edge domains. And we can use all the 5G assets from different platforms and the services and resources they provide. We are exploring the capability of the different platform as well. We are developing innovation in 5G growth stack, but this innovation we can also exchange with other project and ICT17 platform to leverage on the enhanced capability of all the platforms. And we are working on the interworking on across different platforms, and in a way we try to leverage on standard interfaces or design the standard interface to enhance this collaboration. And sure, from this experience we are learning all from each other. So that's all from my side.
Thank you very much. So we can now go to Manuel. So Manuel,
so I have to stop sharing, right? Let me check. Where's the button?
Hi again, Carlos.
Sorry. Oops.
Just to follow the trend, I will project a slide and I will give an answer to your question.
Okay. So you need to tell me where to make the stop of sharing. Somehow I lost the button.
Anyway, Manuel,
do anything?
If Manuel starts presenting, I think okay, that's it.
Okay.
Okay. Hopefully, I'm presenting.
Yes, you are.
Okay, it's so many things we have commented and discussed along the session. The very first one is that in this round of projects, we are talking about 5G for real. And this is very important. The confidence in the conclusions that the verticals can get is something that can be extrapolated to the initial deployments of 5G in Europe. I don't think how we can really stress this. It's so important that we are touching real technology and we can play with configurations that then we can decide for ordering using in commercial deployments. That's to me an important aspect that can run in parallel with a number of innovations that we are developing in the projects. For so many things we have been commented on, incorporating artificial intelligence, on improving the orchestration and management, slicing in general, and so on. That is a very first thing. I selected this slide because I think that ultimately we can automate the solutions for helping projects and verticals to go through this process. That can be, the solution can be automated, but the problem has to be understood and discussed. And at the same time, it's not good to prejudge on the results. Let's benefit from the possibility of experimenting. The way we see it is that we can have iterative testing and validation of the scenarios, not only of the use cases, so that we learn and then we can decide what to do in our product exploitation plans, each of the partners involved in this project. In order to do so, we have to be engineers. Let me put it that way. We have to go through this process of thinking. We can't outsource thinking. We have to use our thinking, put things together, and then use the tools. The best tools that can help us actually achieve the goal of being able to validate a use case. I think we are in that interesting moment. now in the round of projects we are meeting today. And even in these tough times that we are living in Europe with all the pandemic crisis, I'm so sure that actually that type of situation is proving that this is the right approach, that we can collaborate across countries, across partners and projects. We can automate as much as possible all the actions involved in a full validation cycle, and we can find the common tools and use them for a variety of use cases. So that's my conclusion, or my proposed conclusion for today, Carlos.
Okay, thank you very much, Andrés. So, Antonio?
Yes, well, I didn't prepare a slide, and I'm going to be super fast because I have a work next in my window and they have started cutting something. So the noise is really, really bad. Sorry for that. Well, 5G Dive is, as I have explained, is a little bit different project because we work not only with European projects but also with Taiwanese ones. Okay, so we collaborate with a lot of different people coming from different backgrounds. In the European side, I will say that our main collaboration focus will be with 5Growth because we share, apart from different partners, we also share some use cases. Okay. And we will start very soon, try to also collaborate with 5G because we would like to use this platform at least a little bit to test our 5G connectivity in Europe. Said so, I will say that the key characteristic of collaborating with other projects at this point of time is that the complexity of what we are trying to achieve is so high in general, okay, in all the phase 3 European projects, that we cannot do it alone. I mean, it's simply as that. We have to rely on other projects' developments and in other project research in order to achieve our objectives, because it's impossible that in 2 or even 3 years we are able to do all the testing and all the validation considering the 5G technologies and the evolution of them that the European Union want us to do. So that will be my main takeaway message, that we really need to collaborate among ourselves in order to achieve our goals. So this is the main message. Thank you.
Thank you, Antonio. So now it's turn for Marco.
Yes, can you hear me?
Yes, loud and clear.
Okay. So yeah, basically, I kind of share the same conclusion from the people who spoke before me. And as for 5G tours, we are also trying to collaborate a lot with other projects for different reasons. I mean, in this webinar, we presented a joint collaboration between 5G Tours and 5Growth on the introduction of AI in the network management, virtual radio access network in this case. Another collaboration that from 5G Tours side we have ongoing is the development of a proof of concept for the ETSI ENI ESG with colleagues from 5Growth again and 5G. And of course, as an ICT 19 project, we are collaborating a lot with 5G, especially for the infrastructure deployment in each of the test sites in which we have in our consortium the relevant partners that can help us to integrate our technology with the 5G one. So as a summary, I would say that collaboration is really needed, especially in this moment in which I think that several projects have identified what are really the missing gaps. So we think that by collaborating, we can get to them faster and better.
Okay, thank you very much, Marco. And now we can turn to Christos. Christos?
Hello.
Yeah.
Yeah, just I have just one slide to share with you. I hope you can see my screen. Okay.
Yes.
So yeah. So these are the. I would like to recap to the challenges that we encounter as a facility, at least. First of all, there is a difficulty from the vertical to understand what we offer, what are the offered services, and how we can interact with this. And of course, we try to make a lot of training sessions and help the verticals understand all the technologies from 5G world, NFV world, SDN world. Big challenge is the automation of services. We need to help them create these artifacts from the NFV world and create these service templates. Of course, the goal is orchestration, the end-to-end orchestration, which is very difficult because we need to have the above artifacts. Otherwise, we don't have any orchestration. We just stick to just providing a pure only the 5G system. Crucial for us is the interconnection with the facilities, but also with the services that they offer. And here we need to interact with both commercial but also open source solutions. And here, of course, the way is to follow standards. That's why we follow the standards from ETSI and TM Forum. There is a challenge with integration with new locations. We explore the non-public networks concept, but also the autonomous, let's say, deployment of 5G system. Another challenge is this definition of service parameters and KPIs. Many times the verticals don't know exactly how to express a service parameter that they would like to expose. 5G standalone is now a demand, let's say, somehow a demand from the verticals. At least in VRAIN, we try to have available in some facilities, at least in 2 facilities available in the next months. Somehow orchestrated, but at least the goal is to have 1 third slice support. And we hope after, let's say, October, November, to have at least 1 orchestrated solution with 5G standalone. Last but not least is what the vertical expect versus the 5G system. At least in some cases, we have seen use cases that the 5G system currently cannot deliver in the term of radio, core, or UEs. For example, we have a lack of UEs, modems, etc. We have only some mobile phones. Orchestration and multiple slices is a research. At least in our view, we need to invest here. And currently, at least what is readily available is enhanced mobile broadband type. Still, URLLC and massive machine type of communication is something that we need to investigate in future and offer it in verticals as the 5G system is more mature. Okay, that's it from my part.
Okay, thanks a lot, Christos. I don't know if any attendee has any question to the panelists. If not, I want to ask some question, although I think it has been partially tackled, but I would like to ask the opinion of the panelists in how they have how this COVID-19 experience situation, I don't know how to call it, that we are living has modified the way we are doing this collaboration among different projects, and what we have learned, which I think we have learned a lot of this, that we believe that could be applied in the future when we get back to the normality or whatever we call it, hopefully in the next few days. I don't know if somebody has any comment on this.
Well, I can comment. I think that we are used to some ways of working in collaboration projects. We take any opportunity to meet face to face, to discuss things with partners, and we also hope to fix problems and to come back with solutions after those meetings. That's a little bit part of the past. I mean, for 2 months and a half, it's not only that we are using online tools for meeting, is that we are being more effective because we know that time is not elastic in dealing with that. And this applies to the partners within a consortium and in the relationship between projects as well. In my case, I can share at Ericsson we are so used to use testing facilities fully industrialized that you never have to visit at all. You can do all your testing work for the portfolio development remotely. In the setups we have in this round of projects, we are more used to come to the lab because we love technology. We love the high touch feeling. And because we are dealing with technology that came yesterday, a new device that comes tomorrow, and we need a cycle of doing things together in the real place. I think that this is something that will continue. We have to optimize the way that we work. Of course, take any opportunity when we are in something like a normal situation after this crisis. But as I was commenting in my presentation, any tool we can use to remotely be present in the labs that we have is essential to be put in place now. That's the type of work we are doing with 5G, making it possible that by no means you have to step in the lab, but when you can, you will, and that's important. I think we have to learn from this, and I think that we are gaining velocity again, actually.
Okay, thank you, Manuel. Thanks. I saw your view on this, and I don't know if any other panelists or the panelists wants to comment on this point.
Yeah, maybe I can add something on top of what Manuel said. Yes, basically the infrastructure, I totally agree with what Manuel said, is important and has to be made ubiquitous so everyone can access independently of the circumstances. But also from an ICT 19 project perspective, such as 5G Tours, we kind of try to put our effort also in okay, how to make the situation a bit better, and we actually modified a bit our use cases to, for instance, the AR VR use cases we are developing will be now also focused on identifying if the minimum distance between people is met. So from the infrastructure perspective, this has changed a lot, and also from the use case perspective, this has also brought something into the picture.
Hi, Yoshi. Can I also add something from my side?
Sure.
Can you hear me? Okay, yeah. So from the perspective of 5G growth, so we have, as I mentioned, we have 4 vertical pillars, and most of them, for doing any experiment, we need to go to the facility of the verticals. And due to the COVID-19, so that's become a very challenging or impossible task to allow the people to do or set up the devices and access the devices to do any experiment. So what we have been trying to overcome or try to avoid any delaying of the task. So we are also trying out, for example, using more, I mean, before the going to the vertical sites, we're also doing some lab environment testing. For example, we have the Photonic as also one of the location we can do some experiments. So we are also, for some of the use cases, we also start some initial testing or try to find a solution to do some partially of the experiment with such an environment. So until the situation becomes better, then we can also slowly try to access the vertical side to start doing the planned experiments. So that's the situation we are trying to overcome.
Okay, thank you, Tim. So
Yes,
yeah.
Yeah, actually, the situation is also the same almost with facilities Of course, with the projects, at least what we did the last 2 months was to earn some time with with automation. We would like to, to educate people to learn the NFV world, the 5G system, etc. And now some partners deliver to us their equipment because they cannot travel in any case, and we install them here to our facility. It affects a little bit our plans. We certainly hope not too much because even orders from other countries cannot be fulfilled now immediately. There is a late in the schedule, but somehow we continue at least with what we can.
Okay, thank you, Christos. So I don't know if there is any additional question from the audience or from the panelists that we want to tackle. Otherwise, we are 3 minutes past the originally scheduled time, so I think it's a good time for thank you again all of you for being here, for participating in this online experience. I hope that you learn and you took any new learning and takeaway message from this workshop. And if nobody has anything to add, I think we can close it here. Thank you very much, and let's keep in touch doing this collaboration among different projects.
Carlos, before closing, explain how are we going to deliver this recording.
So basically, yeah, the recording will, as I mentioned at the beginning, it will be put on the YouTube channel of vGrowth, and it will then, I guess, it will be published by the different projects on the different websites. So as soon as we have the video edited, which shouldn't take long, we will post it on the vGrowth YouTube channel, and you can take it from there. Okay. So then, thank you very much again, and let's keep in touch. Thank you. Bye-bye.
Bye-bye.
Thank you for arranging everything. Thank you so much.
Thank you. Goodbye.